Hi champions, how are you all? I hope every one of you is doing absolutely fantastic. So this is your chemistry expert Sanjay Arya sir. Today we had some shortage of studios and that's why we came a bit lately. But now I think everything is absolutely fine. You can properly hear me and you can properly see me. I'm properly visible and audible to every one of you, hopefully. And if I'm not, just do let me know in the comment section. Okay, great. So now we have JEE 2026 series in the continuity. Last chapter was mole concept and today we'll deal with complete mole, atomic structure. So structure of atom is very important chapter as far as the concern of 11th standard physical chemistry. And apart from atomic structure, it has wide and vast application throughout your physical and inorganic chemistries, because it will teach us, at last we will study about the electronic configuration, that is very important for complete chemistry. So yes, you all know me. My name is Sanjay Arya, completed BTech from IIT Ahmedabad, more than 10 years of experience and mentored over 5 lakh students, producing some very good double and triple digit rank. Now coming to one very important announcement for all of them who are right now preparing for JEE 2025. Guys, we are conducting our all India mock test. So please go to the Unacademy application, go either of the or any of the community posts you can find, and the description is also given with this enrollment link. Go enroll there. It's absolutely free of course. You can examine yourself, giving a proper live model of your exam JEE Main 2025. Now let us start the chapter. First of all, we'll take a quick roadmap of this chapter, that how are we going to start this chapter, what should be our way of flow for this chapter. So let me give you an idea that what is atomic structure based upon. So guys, at start we will study some basic terms. We will know what is an atom, what is atomic mass, what is atomic number, what are isotope, isobar, isodiapher and all. Then we'll come to the discovery of fundamental particles. So the major fundamental particles of an atom are the 3 subatomic particles called as electron, proton, neutron. Their discovery, we will learn something about them. Then we'll come to some atomic models. Atomic models will basically contribute your Thomson's atomic model, because Dalton's atomic theory is something which we have already covered in our previous chapter of mole concept, so we don't need to repeat that part. We will directly go to Thomson's atomic theory or Thomson's atomic model, also called as plum pudding model. Then we have Rutherford's planetary model. It is Rutherford's atomic model. Then we have Bohr's quantized model. Then we have the most modern one, we can call it wave mechanical or quantum mechanical model. Correct. So in the meanwhile, right after the failure of Rutherford, we also study the dual nature of electromagnetic radiations. So electromagnetic radiations possess 2 types of nature, and hopefully in that we will study both. One of them will be the wave nature, and wave nature is pretty obvious that any wave can show the wave nature, or any radiation can show the wave nature by some important fundamental properties of reflection, refraction, diffraction, interference, etc. And the particle nature will be shown using 2 of the important parts. One of the phenomenon is your black body radiations, Planck's quantum theory, and then we have photoelectric effect. So these are the phenomena that will prove the particle nature of waves or radiations. Then we will also come to the dual nature of matter. We all know that matter has particle nature, its mass, momentum. But does it also contain the wave nature? That will be explained by two important phenomena. One of them is called as de Broglie hypothesis. Another is called as Heisenberg's uncertainty principle. So this is what comes under this part. And right after this, once we all complete this part, then ultimately we will reach to the quantum numbers plus how to write the electronic configuration of all the elements. This is how our flow is going to be for today. So just take an idea, start making your notes, write down every single topic, every single part, and cover it. So this is our today's target. We have to cover each and every topic written over there in the board and in a proper sequence. So let me start it from some basic terms of an atom. So what are these basic terms? So guys, atom require an atomic symbol first of all. So every element has an atomic symbol. So let us just take an idea that sodium is one element. So we have an element, let the element be sodium. We will use its chemical symbol. Its chemical symbol is Na and its atomic representation. Its atomic representation is Na 1123. Now we have come to these two new things, which is 11 and 23. What are they? Well, this is not a big thing. We have already covered this part in 9th standard if you have studied 9th standard properly. So guys, Na is the chemical symbol. 11 is called as atomic number. 23 is called as atomic mass or mass number. This is the atomic symbol only. Now I'll give you the brief idea. First of all, about atomic number. Z. So basically atomic number is what? The unit positive charge. The unit positive charge present inside the nucleus of an atom. So how much is the positive charge present inside the nucleus is called as the number of, like atomic number. And we also know that protons inside the nucleus of an atom contain a unit positive charge, positive E. So as many as number of protons are there, that will become the number of unit positive charge, and that is exactly equal to the atomic number. So Z is also equals to the number of protons in nucleus of an atom. Also take one thing, note, let's suppose if some entity is electrically neutral. Let us take an example of an atom. So we all know that an atom is always electrically neutral. So for an electrically neutral atom, we will have same number of electrons also, the number of protons, and let us say Z will be equals to the number of protons will be equals to the number of electrons if something is what? Electrically neutral. So this is what? For a neutral atom. If something is in ionic form, then it will definitely be having different number of atoms and electron and proton, like that. So guys, I want to add one more thing from here, like how I derived this whole data from. So we have to assume an atomic model in such a way that here is the nucleus, and nucleus is basically made up of only two things. Nucleus, and this contains what? Protons. Inside is the protons and neutrons. N0 is neutron, P plus is proton. Similarly, we have to assume it that electrons revolve in the shell and they remain outside. So outside are the actually electrons, and this is an atomic model that was proposed by Rutherford itself. So this is Rutherford's atomic model, and from that only we got to know about these basic terms of atomic number, atomic mass, and atomic electron, proton, and all. So remember that the mass number, which is also represented by an alphabet A, a symbol is A, also called as atomic mass, is exactly equals to the number of unit mass. Unit mass is U, unified mass U, number of unit mass in the nucleus of an atom. So nucleus of an atom contains how many number of unit masses of U. We also know that the mass of a proton is 1 AMU nearly. Mass of neutrons are also nearly 1 AMU. So as many as the number of protons plus neutrons will be there, that will be exactly equals to the mass number. That is what it contributes in terms of mass. We actually consider electrons as massless, comparing the mass with proton and neutron. And we will also come to know, when we will be doing the discovery of all the fundamental particles, there will come to know that electrons are exactly taken as massless with comparison to proton and neutron. What's wrong here? Not a problem. Now coming back to my topic, I said as many as number of protons and neutrons are there collectively, which is called as number of nucleons, collectively called as number of nucleons, is equals to the atomic mass. Okay, so atomic mass is also equals to mass number, which we are saying A. So that's it. Now talking about the number of protons, electron, and neutron. So guys, let us take an example. Let me take oxygen as an example. And oxygen has an atomic number of 8, mass number of 16. So guys, if somebody asks us what is the atomic number, you will say 8. What is the mass number that has been given here? 16. So what if I say that number of protons will be how many? So protons are equals to the atomic number only, which is 8. Number of electrons, since it is a neutral species, there is no charge, proton and electron will be the same. In order to maintain the electrical neutrality of the atom, it will be 8. And what about the number of neutrons? Number of neutrons will be what? Since A is equals to number of protons plus number of neutrons, so you can find out the number of neutrons is equals to A minus Z. That will be equals to 16 minus 8 is equals to 8. Anyways, everything is 8, 8, 8 here. That is for one atom. That's for one oxygen atom we studied. Okay, clear? Now I'll take you to one more example where I'll give you some iron. So let us take the ion be oxide ion only, O2 minus ion. So now since it is an ion, it is acquiring more number of electrons than its proton. That is why it is acquiring a negative charge. So the number of protons will still be Z, will be 8, A will still be 16, they will not be changed. Number of electrons cannot change the mass of the entire species. So now we'll say, if we talk about the number of protons, will be 8, but electrons, it will be whatever the 2 negative charge is there, 8 positive 2, because if it is carrying a negative charge, that means number of electrons have increased, and 1 unit charge is possessed by 1 negative unit positive charge is carried by 1 electron. So as many as the charge is present there in the terms of negative, that many number of electrons are there. Similarly, if the charge is positive, that many number of electrons would have released out or would have removed out. So electron will be 8 plus 2 is equals to 10. And that's why electrons are more than proton, and it's a negatively charged species. Number of neutron will be exactly the same, that is 16 minus 8 is equals to 8, and that's how you can calculate every information for given ion. Now let me take you to one more example. Aluminium 3 positive. Aluminium 3 positive is the ion given to us, and let's say the symbol itself says that this is 13 and this is 27. and 13. Okay, so how can we do it? Check out the solution. So here Z is how much? Z is 13. Atomic mass is how much? 27. Protons are always equals to Z is equals to 13. Electrons all depends upon the charge present there. If it is a positive charge, lesser number of electrons are there. If it's a negative charge, more number of electrons are there, then it's protons. So electrons will be 13 minus 3 because there's a 3 unit positive charge. So I'll do minus 3 and it will become 10. Neutrons is very simple, A minus Z. How much is the atomic mass? Atomic mass is 27 minus 13. I guess it will come up as 40. Now you are hopefully very much comfortable in calculation of all the subatomic particles, whatever it is required, we can do it. Then comes some one question is here, everybody. One question is here. Please try this question. If Z represents the atomic number and A represents the mass number, the number of neutron can be calculated as what? So always remember that A is equals to mass number is also equals to the number of nucleons, which is the number of electrons, sorry, number of protons plus number of neutrons. So since we already have this and we know that number of protons are equals to Z, so that is why we can simply say that number of neutrons will become equals to A minus Z. Correct answer should be B. Let us move from here and let's reach to another important terms called as isotopes. So how can we call some atoms as isotopes of each other? So these atoms belong to the same element. So hydrogen, if element name is hydrogen, so 1H1, 1H2, 1H3, these three are the isotopes of each other. One of them is called as protium, deuterium, tritium, and these all are having identical atomic number but different atomic masses, and that's why we call them isotopes. One thing. Number two thing is isobar, and these are the atoms of different element which might be having different atomic numbers but same atomic mass. So see, can you see? So let me just give you some example, everyone. So let us say that if we talk about isotopes, the category or the family of isotopes belongs to the same element. So the correct like the example should be hydrogen 1H1, 1H2, 1H3. These are called as protium, deuterium and tritium respectively. So we can see that their atomic numbers are the same. Atomic number 1, 1, 1, but the mass number is 1, 2, 3. These are the examples of isotopes. Now I'll take you to the example of isobars here. So as the name itself suggests, isobars. Actually, isobars will be having different atomic numbers but same atomic mass. So they all belong to different elements. Now take the example of let us suppose argon, atomic number 18 and its isotope with mass 40. Potassium with atomic number 19, mass number 40, and then calcium with 20 atomic number, mass number 40. Can you see the mass numbers over here which are exactly the same? So now you can find out the value of Z will be 18, 19 and 20, but atomic mass will be 40, 40, 40. These are called as isobars. Okay, next term is called as, another term is called as isotones. So guys, isotone means same number of neutron, and we since all know that neutrons are actually a minus 2z, no, a minus z only. So and a minus z will be same for two things, Hana? We can pick the same example, argon, potassium, calcium. Atomic numbers do not change, 18, 19, 20, but mass number may vary depending upon their respective isotope. Let us say this is 38, this is 39, and this is 40. So if you want to find out the number of neutrons, so how much would it come? 38 minus 18, 20, 20, 20. So these are called as isotones of each other. Correct? These are the isotones of each other. There is one more thing called as isoelectronic species. Isoelectronic, बोले तो same number of electrons. Now let us take this example. Hydrogen, helium plus, lithium 2 plus, beryllium 3 plus, boron 4 plus. And what if I write their number of protons first? So protons will be how many? 1, 2, 3, 4, 5 as per their atomic number. If we talk about their number of electrons, it will be 1 because it's neutral. It's with positive charge, so it will be 2 minus 1, 3 minus 2, 4 minus 3, and 5 minus 4. But you will get the number of electrons as 1, 1, 1, 1. These species are called as uni-electronic species, and that will be in detail studied in Bohr's atomic model. He worked upon uni-electronic species only. So take an idea and note it down. So guys, hello, good evening, and greetings to all of you. I already have done this like interactional part in the beginning of the session, so I don't want to interrupt the flow of my lecture. That's why I'm not responding you, but every one of you are equally important to me. I keep on watching the chats going on very dedicatedly. So if any one of you faces any kind of doubt, meanwhile, you can please ask me. Your greetings are very well accepted, everyone. Thank you so much for your wishes. So now we have another term called as isodiapher. So guys, this is a bit different term. This is a bit difficult term as well. And as we do not know about radioactivity, maybe we need some introductory part to understand the concept, introductory part of the nuclear reaction. So this is how it happens. We all know that there is something called as alpha particle, and later on it will come in very much of our use. It's especially in Rutherford's atomic model. So an alpha particle is a doubly ionized helium atom. So if you doubly ionize an helium atom, so it will become what? This is helium, this is 2 is the atomic number, 4 is the atomic mass. What if we remove 2 electrons out of it? It becomes helium 2 positive, and its atomic number will be the same number of proton, and mass number will be the same 4. It will not be changed. So this has become now an alpha particle. And initially it was what? Helium atom. We can also say that nucleus of helium atom, because helium contains 2 electrons only. If you remove all the electrons, then what will be left? Only the nucleus of helium. Nucleus of helium atom is also, is the alpha particle. Nucleus of helium atom is also the alpha particle. So guys, if you remove alpha particle from something, then parent and daughter nuclei will become isodiapher to each other. Take an example. Let us say we have X. So we have X here with an atomic number Z, with an atomic mass A, and we are removing an alpha particle with mass number 2, mass number 4 and atomic number 2. So this will be removing, and this, let's say this is giving Y. So Y is having Z minus 2 as an electron, as a proton over there, and this will be what? A minus 4. So guys, these X and Y are isodiaphers to each other. That is what the definition of isodiapher is. Diaphers to each other. X and Y are the isodiaphers to each other. I can bring one more example over here if you have not understood the concept. So guys, always see that two substances can be said isodiaphers to each other if they have A minus 2Z as same. If they have the same value of A minus 2Z. How A minus 2Z? Because if you do A minus 2Z, it will become A minus 2Z. Here also it will become A minus 2Z because 4 minus 4 will be eliminated out. Next is called as isosters. What are isosters? Okay, so isosters are actually these are also the atoms, could be the molecules. But the interesting part is they must follow two conditions. They should be first of all isoelectronic. Isoelectronic means same number of electrons must be there. Isoelectronic, and number two is they must have same atomicity. You know the meaning of atomicity, how many number of atoms are there in a molecule. Now take this example. N2 and carbon monoxide CO. So number of electrons are how many? Count the number of nitrogen. Nitrogen is 7 plus 7. It will be 14, and this will be having 6 plus 8 is equals to 14. Now what if I talk about the protons? Protons, leave protons here. Atomicity is what? What is the meaning of atomicity? A molecules contain how many number of atoms? How many atoms are there? 2. How many atoms are there? 2. This is, these are same, this is same, this has become what? Isosters to each other. And this can apply to ions also. Let's say cyanide ion is there, carbon monoxide is there, right? We can take ions also, but the number of atoms must be the same and their number of electrons must be the same. They are called as isosters. Isosters, right? Next comes your I don't know why it's not working. So there is a question. Please everybody try this question by your own. Okay, now it is working. So the isoelectronic set of species will be what? You try it. Allow me a moment. I'll be come back. Let me bring my water bottle. Try it. So guys, did you try it? Did you guys try this question? Hopefully yes. And if no, then let me give you the correct solution. It is one of the very easy question that was asked in JEE Main 2019, exactly 4 years back. Question says that the isoelectronic set of species out of these all. So let us just say a trial A only. First of all, let us say A. We have N3 minus. We have oxide. We have fluoride, and we also have sodium positive ion. Now see, the protons are actually the atomic number itself, 7, 8, 9, 10. Not 10, this is be 11. And the electrons will be depending on the charge. So 7 plus 3 will be 10, 8 plus 2 will be 10, 9 plus 1 will be 10, and this will be 10. Since all of them are isoelectronic, correct answer is A only. Wow, yeah, how easy question was that? So that was some easy question, by the way. There we have the next topic of the day. Discovery of these subatomic particles. You all know what subatomic particles are: electron, proton and neutron. So basically, let me give you an idea what subatomic particles are: electrons, protons and neutrons. So why I put 0 there? Means it is of no charge. Let us come. So there's a bit theory we'll cover here, and this theory says about discharge tube, and we also call it cathode ray discharge tube. So guys, there is a initially the first particle that was discovered was the electron. So the most fundamental particle is actually electron, and the first fundamental particle discovered was the electron. So it's a thing of like 1850 around, and many of the scientists were doing the discharge experiment that was actually initiated by Faraday, and electrical discharge in partially evacuated cathode ray tube. So what he used to do, at that high voltage, around 10,000 voltage, the current was start flowing, and a stream of particles moving in the tube from negative to cathode to anode, and they seems like they were originated from the cathode, and that's why they were called as cathode ray. So let me just give you an idea. We have a vacuum pump. It has created a very low pressure. Let's say the pressure is 10 to the power minus 4 atmospheric pressure, very less pressure. Under this less much pressure, an ion and a gas, electron and ion, will be like very much separated towards each other. They will not be in that much number that they can come and can combine together to release the amount of energy. So this is how it is happening. Let us suppose we have taken over here some hydrogen gas. Let us say, let's say initially we are taking just helium gas. Helium gas has been taken. So this is helium gaseous. And under this much amount of energy, under the high voltage which we are providing, high voltage, and under the influence of low pressure which we are maintaining inside the tube, this helium atom gets broken down into He positive gaseous plus an electron, like this. Done? Yes. Then what will happen? This is the positively charged species. It is called as anode rays, and so formed electrons, they will move in one direction. They are called as cathode rays. The collection of electrons is called as cathode rays, and the collection of gaseous cations is called as the anode rays, because it travels from a positive charge to negative charge, because it goes towards the negative charge, and it is like assumed that it is originating from the negatively charged plate, which is anode. And a cathode is a positively charged plate here. So cathode, so that's the difference, cathode rays and anode rays, about their charge and the particle. So now we have got these two type of rays. Now let us talk about the their properties. And every time this negatively charged particle, which are electron, coming in this way, this is the metallic plate of anode, but you all know that electrons are very tiny size, even very smaller, they almost are like no size, and that's why they easily pass through this plate, and they strike over here where scintillations are produced. What is the meaning of scintillation? Some green color discharge has been seen. This is your fluorescent screen called as zinc sulfide screen, and this zinc sulfide screen zinc sulfide screen shows the scintillations after striking it with any particle. So every time a particle strikes there, it glows out in the green color. So that's how it works. Now let us understand the properties of cathode rays. These are some conclusions we drew from this experiment, that cathode rays always travel from cathode to anode. Definitely cathode is actually what is cathode? Cathode is actually negatively charged plate. So from negative to positive charged plate is anode. This is how they are traveling. First point. Second point is they themselves are not visible. Of course, this is very tiny size particle, not visible. But yes, when they strike to the scintillations, they strike to the fluorescent plate, zinc sulfide there, and then some bright flashes appeared. Then we come to know that something was there that was going in a straight line and striking it. Then behavior can be observed by only the fluorescent or phosphorescent material which glows when hit by them, and they all travel in the straight line, and in the absence of electric or magnetic field they travel in the straight line only. These are some basic properties. Next is that they produce a shadow of an object placed in their path. Since they produce shadow of an object placed in their path, we can conclude that they are traveling in straight line only, because we all know that light travel in straight line, and whenever we stand in the path of the light, the encroached area or the one area which we are stopping, the objection provided to the light and its path will be will create a shadow. So that's what it works with these rays also. Anything, an object coming in their path, like this is the object, this is the shadow. And what is this green color? Scintillations. Then we have, it also produces the mechanical effect, like if a small light paddle wheel is placed there, it starts rotating. That means it contains mass. So this is not just a wave which is passing through there. It's not just a radiation. It is also some mass containing particles inside it. And that is what we derived it, like in the presence of electron. And they are also containing mass which is rotating the paddle over there. Then in the presence of electrical or magnetic field, the behavior of the cathode is similar to the negative charge particle. So you see that in the electrical or magnetic behavior. So let us suppose if I apply positive charge plate here and a negative charge plate here, and I ask to pass the electron beam through here. This is an electron going, it will go and it will move like this. So why is it moving like this? Because it will be attracted towards the positive plate of the applied potential. Very simple. Opposite charges attract each other, negative charges repel each other. So that is how we come to know. Also, in the presence of electric or magnetic field, the behavior of cathode is similar to the negative charge particle. Okay, done. The characteristic of cathode rays does not depend upon the material which we are using. Why we are saying it? Because guys, if let's say we are taking helium, so helium will produce He plus electron. If we are taking lithium, it produces Li plus electron. If let us suppose we are taking hydrogen, and let's say it produces H positive and electron. We are taking oxygen and it produces oxygen positive plus electron. So what you are observing, that this portion which is the gaseous cations, which is also called as the anode rays, is actually different for all the different species. But what about these electrons? Wherever they are prepared from, they all are identical. These are your cathode rays. So these all are identical particles. But what we are getting as a product of anode rays, like all are different. So all are different particles. The conclusion says that the particle flowing from cathode ray tube have mass, negative charge, and must be present in the atom of every element. That is why these are terms as electrons, and these electrons are actually negatively charged, and these are the properties mentioned. Hopefully I have covered this part. I have explained it wonderfully. You people are getting me what I'm trying to explain? Everything is self-explanatory here. This is my notes. This is the beauty of my notes. You can download these notes from our Telegram channel. The link is given in the description. Go today and follow it. Description, you can find our channel link. Then, so guys, this is something which is beyond our syllabus, and I don't want to what should I say? Let me just take you very simply from here. Most of the people have doubts in this topic, and let me just give the clearest way possible. Calculation of charge versus mass is very much asked in the terms of electron. So sometimes question comes, which was proposed first, which came first, charge or the mass? So it's more or less like the which came first, the anyways. So what we can do is, so there are like two things. One of them is the applied electric field, another one is the magnetic field. And an electron goes in the straight line if the intensity of electric and magnetic field are the same. And let's say if the force applied on the electron by electrical and magnetic force was the same, then it goes in the straight line. If electrical field is being given more potential, then it gets turned towards A. See, when electric field is applied, and if you are making it like applying the magnetic field, then it goes downwards because of its circular motion there. Then when only magnetic field is applied, and if we are like applying nothing field, no field, or we are just balancing the forces together, then it comes to B. So over B, what you will find, force of electric becomes equals to the force of magnetic. So I don't want to make you people confused. It's a force called as charge multiplied by electric field will be equals to, this is also equals to charge into velocity into magnetic field intensity. So guys, this is somewhere which we know most of the things, and later on performing one more experiment, this is how where we can find out the velocity of electron. Because what do we know about E will be cancelled out, and this is known to us, this is known to us. We can easily identify the value of, what we can find out is the value of V. V can be find out. So this is given, and this can be identified. If you know the velocity, then there is one more thing that we do. Let us say we are in this is north, this is south, and an electron comes, and electron usually comes and take a circular path and then goes. And let's say the circular path has a radius of r. So guys, you will find that force of centrifugal working upon the electron in this circular path is exactly equals to the force of magnetic. This is the magnetic force, because centrifugal force is an imaginary force, and magnetic force is actually attracting this electron. This is helping to leave this path, magnetic field, and leaving the electron into out of this field. So guys, centrifugal field is mv square by r, and we all know the velocity here. We also have the magnetic force, that was qvb. So using this information, this radius of curvature can be determined using the calculation made out there, and then you can find out the value that comes directly. This is your E by m value. E by m value of these all experiments give you what? E by m value of electron, which is equals to negative of 1.7588 into 10 to the power 11 coulomb per kg. See, this is an important figure. That is why I remember this. I know this value. This is 1.7588 into the power 11 coulomb per kg. So initially, what somebody asks, what was discovered first, charge or the mass of an electron? So we will say yes. The very first thing that came was the charge upon mass ratio. Then charge on mass ratio is how much? 1.7588 into the power 11. Why am I putting a negative sign over there? Because the charge is in negative and mass is always positive. Then guys, we did an experiment to find out the charge of an electron. So what we did, we followed Robert Mulligan's oil drop experiment. So what did Robert Mulliken do? So Robert Mulliken had a device called as this chamber. This chamber is exactly containing this is something which is called as atomizer. This is called as atomizer. Okay, I'll name everything later on. This is the spray coming out of the oil. And let's say I can make it more beautifully. Oil, let's say, has a yellow color. It's an atomizer sprinkling the oil drop. Next over here we have metallic plate and conduction. This part is covered, this part is connected to the negative terminal. This part will be connected to a positive terminal. And he also applied what we call it a electronic microscope to look at this oil drop. Oil drop is visible. So this is called as the let's say this is an electronic microscope or some telescope device, which is actually in order to telescope, let's say, in order to observe the oil drop. So let us suppose this is your oil drop, and this is an oil drop. What other apart from that we are having is, we are having helium gas here at low pressure, and we all know at low pressure helium gas will be ionized to produce what? At low pressure it will give you He plus and electrons. Oil drop contains too many of negative charge ion, so oil drop with electrons. So this is containing so many electrons in it. And why is it so? Because we have pine oil here. Pine oil is filled inside, which is a source of electrons, which is something which can abstract and can attract the electrons towards it. Then we also have this device called as atomizer. Atomizer is a device which is producing the oil drops, and then this oil drop with a negative charge reaches here. We'll be having two forces working upon it, here and here. So what are these two forces? Let us see. So guys, you will see that this oil drop, this is your oil drop, has a negative force called as mg, gravitational force. There's one more force which is electric field multiplied by charge of oil drop. So when we equated this force called the force of electric force, when we equated these both, it keeps on jumping like this, and we make it to held somewhere. Then we come to know that charge of any species, now let us say it is an oil drop, is quantized in nature, and every time in the experiment he found the smallest value that comes in the terms of some number is n multiplied by 1.6 10 to the power minus 19 coulomb. And since it's a negative charge, we'll say a negative charge here. So we will say a conclusion from here that n is the number of electrons. This is the charge of one electron. So we'll always say that charge is quantized in nature. Charge is always quantized in nature, and always, why am I saying it always? Because the smallest possible charges of electron, and always will be, and it will always be an integral multiple of E. What is E? charge of an electron. So what we have discovered? We have discovered the smallest charge possible. So smallest possible charge is equals to E is equals to 1.6 10 to the power minus 19 coulomb, because this has been derived from the charge of an electron itself. So electron has a charge of 1.6 10 to the power minus 19 coulomb. That was given using, that was determined using oil drop experiment by Robert Mulliken. Next comes mass. We have two things discovered till date. One of the charge of an electron, that is equals to E, that is minus 1.6 negative E 10 minus 19 coulomb. E is a symbol, E is the smallest charge possible, that is 1.6 10 to the power minus 19. If we are saying minus E, then it is the charge of electron, negative charge, like that. We also have that E by M ratio. We determined it to minus 1.7588 10 to the power 11 coulomb per kg. If you use this information and you find out that E upon E by M, everything will be cut out. You will be getting mass of an electron is equals to positive 9.1 10 to the power minus 31 kilogram. Just learn it. It's a very important unit we need to know. 9.1 10 to the power minus 31. I think this is absolutely clear to all of you. Mass of electron now you've got. So everything we have got about electron, and now come to the proton. So guys, when we used hydrogen in the same experiment, if we use hydrogen gas, so what did we have? High potential and very low pressure. First of all, in the influence of energy, it broken down. It gave you 2 hydrogen gaseous positive. First of all, it will be broken down. First it gets broken down, 2 times of H gaseous. Then it releases hydrogen positive gaseous plus electrons. So guys, in this basically way, when we took hydrogen gas inside that chamber, inside the cathode ray tube, we got H positive over here. This H positive later on termed as proton. So basically, what did you see? That protium loses an electron to give what? H plus, called as proton. So that is what you got the name it from. Protium releases 1 electron to give you what? Proton. So same experiment, if we are taking hydrogen gas, then anode rays will be carrying H positive ions with them, and that H positive is itself called as the proton. You can check it out over here, that we all know that hydrogen atom, one hydrogen atom 1 has how many protons? Z is 1, so his number of protons is equals to 1, electrons is equals to 1, and neutrons are 0. So what if you remove 1 electron out of it? It will become what? H positive 1. So how many are the protons now? 1. Electrons 0. Neutrons 0. So this itself is actually a proton. Since there is no electron, no neutron, no anything else, this species what we are getting H positive is actually a proton. So we have discovered proton, we have discovered neutron, sorry, we have discovered electron also. And in order to make the overall atom electrically neutral, so hydrogen since contains 1 proton, 1 electron, and an electron has a negative charge, so definitely proton will be having equal and opposite charge of the electron. So proton has positive 1.6 10 to the power minus 16 minus 19 coulomb, sorry. So that is what we got let me simply write that charge of a proton will be equals to positive E is equals to positive 1.6 10 to the power minus 19 coulomb. And what is the mass of proton? So applying the same experiment, you can find out the value of E by m, and then after E by m you've got the mass of proton, that is 1 point, which is exactly equals to plus 1 u, nearly, but exactly it is 1.672 10 to the power minus 27 kilogram. So this mass is roughly equals to 1 atomic mass unit or 1 unified mass. Check it out, everyone. This is the discovery of proton which we are doing. We have got the proton, electron, their charge, mass, everything. There comes the next, neutron. How did neutron form? Neutron was discovered by James Chadwick, who was a scientist working upon some radioactive experiments and some of the nuclear experiments. What did he do? He created a resource. This might not be looking like a resource to you, but I'll make it. The edge is calling me. This is source of alpha particles. This is the source of alpha particles. This cage is exactly a lead cage. Lead has a property to absorb the alpha particles, so it will not go here and there, it will go in the direction where we are needing it. So this is how it will be producing the alpha particle. Then we pass these alpha particles through a narrow slit of lead. This is a narrow slit of lead we are having. This is the narrow slit. This is the opening. Okay, so this is actually this is narrow lead slit. So what does it do? It makes them to pass in a linear. We also call it, or we call it collimator. So collimator is doing one thing in order to make these alpha particles pass in a straight line. So now these are passing like this. This is the beam of alpha particles. And what is it striking upon? So let me take another sheet. This is your beryllium. Beryllium sheet. So this is the experiment outlook looks alike. And what's the outcome of this thing is that whenever the beryllium atom strikes, and specifically the nucleus you're talking about, the beryllium atom strikes with an alpha particle producing a nuclear reaction where mass and the atomic number and everything is very much conserved, but we had production of the carbon C12, and along with that one of the particle was produced which has mass but it did not deflect. You will see that if we are applying a positive charged plate and a negative charged plate and we are passing a neutron, it passes undeflected. Means this is not concerned of the electric field. This doesn't get affected by the electric field. This is called as neutron, which had mass but didn't have what? A charge in it. So I'll give you the idea. So how much is the charge? Charge of a neutron is equals to 0. E is equals to 0. Then we have mass of neutron will be how much? The mass of neutron is exactly 1.675 10 to the power minus 27 kg, which is approximately equals to 1 U or 1 atomic mass unit. But honestly, actually what we are taking is the relative mass, but actually mass of proton is too much, not too much. Mass of neutron is greater than mass of proton and very slightly greater than, right? Slightly. And they are very, very greater than mass of an electron. Highly. So now you have derived all the masses and charges and everything for all the fundamental particles. So now to take a quick recap whatever we have studied till now. So we had absolute charge, which is negative 1.6 10 to the power minus 19 coulomb for electrons. So this is in coulomb. This is also for coulomb. This is also 0 coulomb. Then relative charge means with respect to E, the charge of electron. So positive E is possessed by proton, negative E is possessed by electron, and 0 E will be possessed by neutron. So minus 1 E, positive 1 E, and 0 E. Masses we all know, 9.1 10 to the power minus 31, we derived it for electron, 1.672, 1.675 for proton and neutron respectively. Proton is slightly lighter than neutron, and electron is around 1. It is exactly 1837 times lesser than the mass of proton. So this is how I was saying it's a huge gap between the mass of proton and mass of electron. Rest everything is a bit similar and we already covered this part. The first question comes in our mind. So after this study, which subatomic particle has almost negligible contribution toward the mass? I told you in the start of this lecture that electrons are not even considered while calculating the atomic mass of an atom. Only the mass is contributed by protons and neutrons, and that is why combined number of proton and neutron, which is also called as nucleon, is exactly equals to your atomic mass or mass number, because each of the proton and neutron contains 1 U mass. So as many as number of neutron protons are there, that will contribute to the total mass of an atom called as atomic mass. Correct answer should be an electron. Next is the E by M ratio of cathode ray. Does it vary with the element forming at the anode? Does it varies with the gas inside the disk? Is constant or what? So guys, cathode rays are what? Electrons. So whatever the material you pick, it will always be what? Constant. Which of the following cathode rays will have the smallest specific charge? Smallest specific charge. So guys, do you know what is the meaning of specific charge? Is exactly charge upon mass ratio. Specific charge is exactly what? Charge upon mass ratio is called as the specific charge. So charge and mass. So let us see. Cathode rays. Okay, so it will make what? H plus plus electron, He plus plus electron, N plus plus electron. So let us suppose if we are finding it for anode rays, which of the following cathode rays will have smallest? Because cathode rays are what? Cathode rays are the electrons itself, and all of them are producing the same identical particle. These are the cathode rays. These are the cathode rays with identical particles. Since these are the identical particles, we will simply say all of them will have the same charge. Or they will have the same value of specific charge. Next is for anode rays, it has been asked, and for anode the situation will be entirely different. H gives H positive, forms one electron. Heliums form helium plus and one electron. Nitrogen gives you N positive and one electron. So guys, now we have to talk about these three particles. So for this is like Q by M will be what? Charge is how much? Positive 1 E upon how much is the mass? 1 U for hydrogen. So 1 by 1. This will be having a Q by M of charge is positive 1 E and the mass will be 4 U, and then Q by M will become what? 1 E, mass is 7 U, not 7, exactly 14 U. So guys, I think this will be the less. C is the correct answer. Now you rest of the everything you can check it by your own. Millikan's oil drop experiment. We were using it to find out the charge of an electron which was quantized. So B is the correct answer. Finally, we have completed this part of discovery of subatomic particle, and now we have come to the different type of atomic theories. The very first theory or genuine on paper theory right after Dalton was given by Thomson, and that too was after the discovery of electron. So some genuine theory where we can talk about the subatomic particles was given by very first Thomson. Although this theory couldn't work for a long time, it came up with the drawbacks of this theory, and with the discovery of the next, let us see. So we have an atom here which is nothing but a spherical watermelon shaped thing in which negatively charged electrons are embedded like seeds of watermelon in it. So you will see that these seeds are actually electrons with a negative charge, and the inside this mass what you see is actually, there was no proton discovered by that time. This is simply mass with positive charge, and electrical neutrality was maintained. So it has been said that total positive charge was equals to total negative charge. So you know what the interesting part is? What is the interesting part here? That it's Christmas going on these days, and this is also called as plum pudding model. So I know this is not a very cool joke, but it came eventually in my mind. And yes, it is also called as watermelon model, but raisin pudding, plum pudding is going like very frequently going on these days. We had some secret Santa festive here. We also had some party celebrations of Christmas, and you will not believe me, we all received a plum cake, and plum cake exactly looks like this. Not exactly this, but in the spherical shape it will look like this only. There's a cake inside, the raisins are embedded like this. But this is not gonna to work, because Let me show you its failure. Everyone. So guys, if it is a positive charge shell, then a beam of alpha particle, let's say a beam of alpha particle, which are nothing but the positively charged particle, must go and strike and get deflected every time. Are you getting me? So every time it must get some deflection. But majority, more than 99%, alpha particles went undeflected. Can't be explained using Thomson's atomic theory. So Thomson said that this is a whole positive charge. Whatever the number of alpha particles are coming, they all must get deflected. But the deflection was not done for all. The reason is very simple, that the reason is pretty simple, everyone. The light just gone holding me, Valhalla calling me. Then after failure of Thomson, we have Rutherford with us, which is also going to create another failure. Now let's see, what did he say? This experiment of Rutherford is also called as Geiger and Marsden, Ernst Marsden experiment, because these were the we can say the subordinates who were working under Rutherford by that time. So Rutherford's experiment we have all come across in our 9th class. We also know that the experiment was called as alpha particle scattering experiment, where he bombarded a lots of alpha particles on the metal sheet, and that metal sheet was a very thin sheet of 10 to the power minus 4 mm thickness, 10 to the power minus 7 meter thickness, which is like very small, yeah. So exactly like the atomic size is 1 angstrom, and gold has the most malleability, and due to which he picked gold so that he can reach towards, very near to an atom, rather than having the multiple atoms in one line and will be having multiple deflections all the way. So what did he do? He took a high energy, fast moving alpha particles with him and bombarded them on the direction of a gold metal. Then he found, and next to it he also kept a zinc sulfide screen, and whenever alpha particles strike to the screen, it produces a green color scintillation. So this is how rare, it's not working anyways. So everybody, this is your this is zinc sulfide screen, and let's say we are passing some alpha particles here. So let's say this is an alpha particle coming and went undeflected. This is some alpha particle coming and deflected a bit. This is an alpha particle. This is going undeflected. This is coming like this and going at like this. This is undeflected, and this is at large angle. So guys, try to understand what is happening here. Like there are very few which are going there and producing the scintillation here, here, here. But what did you observe? That most of the scintillations will be coming in the forward direction only. Very less were shown at the bigger or the large angles only. Very less scintillations were shown like this. This one, the exceptional case where this bounce back, this one is called as bounced back. The meaning of bounce back is deflected at around 180 degree, nearly 180 degree. So it bounced back only. So instead of going in forward, it just came back in the same direction. So that's how it worked. This is your observation towards this experiment of alpha particle scattering. Now let us come to the conclusion part. Conclusion says that most of the alpha particles undeflected went through that, which gives you an idea that majority of the part of an atom is empty. Then alpha particles being positively charged in nature, they were deflected by the nucleus. That is why nucleus might be having a bigger positive charge, and thus there must be a positive charge inside the atom. Now, as only a few particles deviated, it concludes that the positive charge is very small, and that is what we call as a nucleus. And the positive charge of the atom is concentrated inside the miscellaneous in a very minuscule region. This is called as the nucleus, and nucleus is 10 to the power minus 15 meter of the size. So 10 to the power minus 5 times smaller in radius than an atom, and 10 to the power minus 15 times smaller in the volume. Okay, now I'll take you. Next comes another conclusion that an atom consists of a tiny positively charged nucleus which is placed at the center. This is what atomic model came from. The conclusion: atom nucleus contains zup. I'll give you this idea. Let us see. So guys, he said that center contains a positive charge. Surrounding to that, we have circular paths where electrons are there. Electrons move like this, and electrons are moving like this, but here it contains the nucleus, and nucleus contains positive charge, proton and neutrons also, because the majority of the mass is concentrated inside it only. So that's what it explained. He also explained that the electrostatic force of electrostatic on electron is equals to the force of centrifugal on electron. So whatever the force is working on electron, it is counterbalanced, and that's why electron is not moving anywhere. It's not leaving this particular the path. It keeps on roaming here only. We'll move to next then. So what are the experimental mathematical results? We derived it from the Rutherford experiment. We found that the number of alpha particles deflected at an angle of theta were inversely proportional to the fourth power of sinusoidal of the theta by 2. Theta is the angle of deflection. Then also found that number of particles which are releasing is inversely proportional to the kinetic energy. Higher is the kinetic energy, lesser is the number of particles which are deflected. Number of particles is also directly proportional to the z square, and number of particles is inversely proportional to the r square. Just take this thing in your mind, take an idea. No need to write down everything. Just take an idea, and now we'll come to some question, some numerical part. Try understand this question. It's an important question, and then we'll solve some question. We'll get an idea how to solve these questions. Rutherford experiment is going on. Alpha particles which were deflected per minute from the gold nuclei at 90 degrees, 396. So what we see that a number of particles at 3 at 90 degree are how many? 396. So find the number of alpha particle bounced back in the same experiment. So number of bounce back means 180 degree will be how many? This is what the question is. Always consider one thing over here. Whenever we say that A is directly proportional to B, whenever we say A is directly proportional to B, we can simply write this thing as A1 is equals to constant into B1 and A2 is equals to the same constant into B2. And if you divide this thing, it will become what? A1 by A2 is equals to B1 by B2, or B2 by B1 is equals to A1 by A2, A2 by A1. So this is the formula that we have to use every time, and this is the particular chapter where you'll see this application a lot of times at so many places. So now coming back to our question, we'll do one thing, that we have to find out the number of particles at 180 degree divided by number of particles at 90 degree is equals to 1 upon sinusoidal of 180 by 2 raised to the power 4, and there goes 1 upon, this will go up, sinusoidal of 4 power 90 by 2. So just solve this equation. So number of particles at 180 degree will be equals to number of particles at this will be 396 into. So how much is sine 45? 1 by under root 2 raised to the power 4 divided by, this is how much is 90 degree? Sine 90 degree as I think is 1. This will become 4. So 396 by 4 is how much? 396 by 4. 99 is the correct answer, everybody. C is the correct answer. So that is how you can calculate everything by your own. So this is how you can calculate the value of number of alpha particles at any angle, okay? Somebody over here in the comment section is like trying to troll me. He is saying that, sir, only 3 are watching. First of all, you just need to clear up your eyes. What I can see, like 8 people are watching. Secondly, I must say that this is a new channel we have started. And right now, it's just a start for all the people who are watching, who are preparing for JEE 2026. This is for all 11 standard and new people. And for them only we have come up with this Josh, and we will try to push this channel as much as possible. This channel has the high level dedicated teachers with us. So those students who are absolutely dedicated and want to achieve something in their life, they are most welcomed on this channel. And the students who are trying to troll their teachers, I can see what you people are and what you can do for yourself. Let me keep you in the waiting list. Then we have one more concept called as distance of closest approach. So undoubtedly this is your positively charged nucleus with a positive ZE charge, and there comes an alpha particle. An alpha particle also has a positive 2E charge. So what happens, everyone, like this particle tries to travel from here and coming like this, and then it turns and come back like this. So this is what we are trying to observe till what distance it reached closest to the nucleus. So this distance from the center of this is called as R naught, which is nothing but the distance of closest approach. So there are like 2 things which we have to use. The one thing is at the start. This is what we are located at the rate infinity. We are right now, how much far are we? The radius, the distance between these two is infinity here. and the radius over here is r is equals to r naught, distance of closest approach. So at the rate, so basically total energy is conserved. So total energy at the rate r is equals to infinity must be equals to the total energy at the rate r is equals to r naught. So what we'll do, total energy is what? Kinetic plus potential. So kinetic energy infinity plus potential energy infinity must be equals to kinetic energy 0 and potential energy 0. So guys, you must know that potential energy is the formula of k q1 q2 by r. Now since r is infinity, this whole equation will become 0. This becomes 0. Kinetic energy will be half mv square must be equals to kinetic energy. Kinetic energy will become what? Half mv square, but v over here is 0 because velocity will become 0 at one point where it start deflecting, and potential energy will be k q1 q2 by r naught. Now just equate these two and you will get your answer. So half m mass of alpha particle, velocity at start alpha particle v square must be equals to k is 9 into 10 to the power 9, which is also called as electrostatic constant, or I'll explain every part. K q1 is like z times of e, positive 2e divided by r naught. So guys, using this formula you can find out r naught, distance of closest approach. Done. So that's the concept behind distance of closest approach, everyone. But the exact explanation and exact application can be asked in your JEE advanced examination, not for sure in your mains examination. This concept can come only in JEE advanced. It has already appeared, this question has already appeared in some of the IIT JEE exams in previously as a comprehension based question, but its application in mains has not been seen till date. We'll solve one question, we'll keep our motive higher. So let's see how does this work. We have a question here, everyone. Determine the distance of closest approach when an alpha particle of kinetic energy 4.5 megavolt strikes a nucleus of z equals to 80 and reverses the direction. So we can do like we already know. Total energy at r is equals to infinity must be equals to total energy is r is equals to r naught. So we know potential energy will be 0 here, so we'll simply use half. Mass, how much is the mass of an alpha particle? So how mass is 2u. So 2 into 1.67 10 to the power minus 27 kg. We'll take everything into SI unit. Half m into v square. So how much is the velocity? Okay, it's already saying that it has been given with 4.5 mega electron volt. No need to write down. We will simply write 4.5 mega is 10 to the power 6. Electron volt means 1.6 10 to the power minus 19. Now it has become into joules. This energy in joules is equals to a total energy at r naught, r k q and q2 by r. So k is actually 9 into 10 to the power 9. q1 charge is exactly z equals to 80. So 80 E is 1.6 10 to the power minus 19 into mass of an charge of alpha is 2e. So 2 into 10 to the power 1.6 10 to the power minus 19. These are the charges divided by r. So this is what we have to find out, r naught. So now everything is given to you, solve it and you will get the value of r naught as, let me see the answer. A is the correct answer. Okay, right? So guys, I think I don't need to solve the problem for you. It's a homework. You try it by your own, and I have the confidence that, believe me, you will do it by your own. You need to just try this question, okay? Similar questions are there. Try it as a homework. And then we have reached to the, there's a solution also given. Very good. Drawbacks of Rutherford atomic theory. So Rutherford was doing very well. Rutherford gave a very good explanation and very good scientific approach towards the discovery of an atom. Anyhow, he failed to explain the stability of a system. He was the very first scientist who introduced the concept of nucleus and literally reached to the very great milestone, but could not give you the satisfactory explanation behind the stability. How? Actually, the reason behind its failure is the Maxwell's electromagnetic theory. So according to electromagnetic theory, everyone, whenever a charged particle accelerates, so who is this charged particle? This charged particle is your nucleus. How much is the charge here? Positive ZE. This positive charged particle will be having its aura, its electric field surrounding to it, and over there only one electron will be there. This electron keeps on changing its direction at every point. So basically, whenever a charged particle accelerates in the electric or magnetic field of the another charged particle, it radiates out energy in the form of electromagnetic radiation. So it will radiate out the energy, electromagnetic radiation, electromagnetic wave, or EMR. So what will happen? After time is equals to 10 to the power minus 8 second, very lesser time that it will not let you blink your eyes and it will happen. This much smaller time will lead this electron going and then fall down back into the nucleus. This electron will keep on losing the energy, will anyhow go and just crash inside the nucleus. That makes atom is unstable. If atom is unstable, how come everything is surviving? So that's why the theory of Rutherford fails here. And now let us all welcome the greatest scientist of all the time, and the one who gave the proper quantized model of an atom that was not just helpful for his own term, but also helped many other stories and many other theories, the upcoming theories also, for their own calculations and these statements. We have Neil Bohr with us, guys. Let's welcome to Neil Bohr. Hi guys, I'm Neil Bohr. How are you all? So it's Neil Bohr, not Amitabh Bachchan. Yeah. So what did Neil Bohr do? Neil Bohr actually first of all studied every situation. Neil Bohr was one of the, what I must say, a co-scientist and a researcher working under Rutherford. Rutherford was a bigger scientist by that time. So he was a senior scientist, and that he was working as a junior scientist, Neil Bohr. But Neil Bohr knew that my senior scientist has got failed explaining the concept of an atom. So I must study what are the drawbacks first of all. He woke up for nights and days and he studied about the electromagnetic radiation, electromagnetic theory. And you all people might have observed that while you are studying NCERT, right after studying Thomson model, then we reach to Rutherford model. So all of a sudden, unnecessarily, we reach to electromagnetic radiations. How? Why? The reason is this, that the concept of, or the experimental model, the quantized model of Neil Bohr requires the complete understanding of electromagnetic radiations, because this was the only drawback for the stability of Rutherford's atomic model. So let me take you directly to electromagnetic waves and electromagnetic radiation. Before that, we have some question. So let's try the question. Rutherford atomic model could not explain the presence of electron in an atom. No, it was explained. Presence of positive charge, that too. Stability of an atom was an issue, because according to him, force of electrostatic attraction and centrifugal force balances everything and it will be stable, but theory of electromagnetic radiation was not explained by him. So when atoms are bombarded in alpha particle, only few in millions suffer the deflection because of the very small sized volume of the nucleus comparing to that of an atom. So as I told you everyone, we right now are having AIMT for all the students who are appearing in JEE Mains 2025. The next test is about to happen on December 29th, Sunday, which is like day after tomorrow. So guys, today only go and just do enrollment. Do the enrollment right now. Only description is containing its link, and feel this. At least try yourself. Give a real exam simulation. The same feeling you will be getting in your JEE Main 2025 exam also. Questions are being selected with the latest curriculum, with our very senior team, very dedicated team of teachers working pan India. And you can also predict your rank. Rank predictor is there. Using that, you can also find out where you stand right now, what can be implemented from here, what you people are standing right now on. So this is what you can get throughout. So now we'll continue our electromagnetic spectrum right after a short break. Okay, just take a 5-minute break and then I'll come back and join. I have come back, and it was a shortest break we ever had. Nothing was available actually in the canteen, so that's why I came back early, a bit early, and we'll have some dinner break later on. Now moving forward, we have electromagnetic spectrum. So what is electromagnetic spectrum? How does it explain? Guys, what happens whenever we have, what is the meaning of spectrum? Let us know. So let us suppose that we right now are having, no, let me take yellow only, no. This is sun, and this is called as the white light. This is called as white light, and we let this white light to fall upon a prism, and then this white light gets separates into and this is called as an spectrogram. Spectrogram is actually one of the, we can say, a screen where we are noticing the all lights together, and this light is nothing but your VIBGYOR. This is your VIBGYOR. Maximum deflection is seen in violet. Rest are red is very less deflected. The so formed this separation or this arrangement of various frequency of lights on the spectrogram is called as this arrangement of these so many wavelengths and frequency containing light, or these energies, is called as spectrum. This is spectrum. So now we'll understand this spectrum in a bit detail, and we will go for these all, what is for the every electromagnetic spectrum will go. So guys, remember this part, that the same thing if we go for all type of energies possibly. So like let us suppose we have electromagnetic radiations, and where are they producing from? Produced from, where are they produced from? Accelerated charged particle. So guys, we have accelerated charged particle with us, and that electromagnetic radiations in increasing order of their in this spectrum, how do they look like? So we have learn this number. There is a name of a very important scientist. His name is Ramin Wuxji. Ramin Wuxji. Ramin Wuxji. Remember this name Ramin Wuxji. So I used to make this by my own when I was studying in my class 12th. By that time I made it. Ramin Wuxji. Who is Ramin? RA stands for radio waves, microwaves, infrared, violet, what is V? Visible, ultraviolet, X-rays, and then finally gamma rays. So this is the actually spectrum which we are right now talking about. And now moving left to the right, we see frequency increases, energy increases, but their wavelength decreases. So just take this thing in your mind, take the idea about the electromagnetic spectrum which we are receiving right now. Then I'll explain this part in even more detail with the time. Now first just take the idea what Raman-Wuchsky is. Raman-Wuchsky is exactly the arrangement of all the electromagnetic radiations in increasing order of their frequency. So you can also learn it by writing that rowdy monkeys in video games use X-ray glasses. That is also one of the mnemonic that you can use, and you can learn this particular, and because this will be very much helpful later on. This will be anyhow very much useful to us. Comparing the energies or wavelengths or frequencies of two waves, that is what. Now let us take an idea of what is electromagnetic wave is made up of, and how is it produced. We all know by the charged particle, accelerated charged particle. So now talking about the let's say this is x direction, this is y direction, this is z direction. So this is y, this is x, this is z. So what are electromagnetic waves and how can they travel without any assistance of external thing? So let me just tell you. So let's say this is electric field. This is called as electric field, and electric field has vectors like this. These are electric field vectors. Electric field as a vector quantity, these are the electric field vectors. Then you have magnetic field in parallel. So magnetic field is also over here, similarly with electric field, but exactly perpendicular to the electric field. We have this field perpendicular to the electric field. My diagram might not be looking that well, but my explanation will be, this orange part is your magnetic field vectors. This yellow lined part, this yellow lined vectors are electric field. So guys, you know what? Moving electric field produces magnetic field. Moving magnetic field produces electric field. And that's why they keep on producing themselves, and it does not even require, the electromagnetic radiation does not require any medium to travel. They can travel even through vacuum. This is your electromagnetic radiation, and that direction x-axis, this direction x-axis is actually the direction of propagation, in which the wave is moving, direction of propagation. And this contains the maximum velocity that anything can has, 3 × 10⁸ meter per second. Now we'll discuss all these important points one by one. First point, the oscillating electric and magnetic fields are mutually perpendicular each other to the direction of propagation in which the wave is moving, that is x direction. Now, unlike the sound waves, they do not require any medium. They can travel in whatever the medium available, even through the vacuum. There are many types of electromagnetic radiations, and for them spectrum we already have come to know, and they all will be moving with same speed, and they all arranged in a increasing order of their frequency is called as the spectrum that we just came across, electromagnetic spectrum. Rowdy monkeys in video games wear X-ray glasses. Then electromagnetic waves are not deflected by electric and magnetic field because they already are producing electric and magnetic simultaneously. Electromagnetic waves are transverse waves, and they do not need no medium to propagate. We have done it. and then wavelength and frequency related as this. So anyways, I'll come to this point. One. So guys, the meaning of transverse is those kind of waves in which the, what we can say, the vibration of the particle is along the direction of is perpendicular to the direction of propagation. You can see the electric and magnetic field directions, and this is called as the transverse waves. There could be another one called as longitudinal wave, which are the one in which along the direction of propagation the this vibration might be there, but not required as of now. We can skip it for a while and then we'll come and continue everything. First of all, take this example that spectrum that we are receiving could be of two types. One of them is called as emission spectra, another one is called as absorption spectra. Emission is a bit more important, that we'll study right while after of it. And right now what we are having is, this is a source of light. So this is a source of light, source of basically electromagnetic radiations, EMRs. We make it to fall upon prism, it deflected so many things, and then this is how the spectrum has attained to us. With all dark background, what we are seeing is a dark background and only visible lines. Only visible lines and dark background is called as your emission spectra. And the negative copy of this, the negative copy is made when we supply the light source or supply the energy of electromagnetic radiations towards the sample first, and whatever the sample there are some electrons might be in ground state, they acquire energy, they get higher energy, and rest of the energy is passed, rest of the radiations are passed through the sample and are allowed to basically propagate over the photo basically spectra, where we see that on this photographic plate you will see all the lights visible. Only those lines will be missing that were used in acquiring the ground state to higher state jump in the atomic sample. That's what it works. So absorption spectra is exactly the negative copy of emission spectra, where you will see exactly opposite. Opposite as in, we will be seeing a visible colorful background and dark lines are there, which are representing the atomic spectra. Line spectra is actually the atomic spectra. So that's how we do. I hope the part of this spectra is pretty much clear to all of you. And now we'll move forward. We have some main characteristics of a wave that we have to learn it right now. Only you people have gone through this in your junior classes also, specifically of your 8th, 9th and 10th. But still we'll take another idea of wavelength and then frequency and everything. The very first term that comes is the frequency, represented by this term called as nu, a Greek letter nu similar to V, small v. Then the number of waves that are passing through a particular point in 1 unit time, in 1 second. So units will be second inverse, called as Hertz, after Heinrich Hertz, one of the scientists. So this is how we have taken. Okay, so if what we see that there are like high frequency means more number of waves are passing in unit time. This is your actually time. So if lesser number of waves are passing in a unit time, then it will be having low frequency. Then we have wavelength, called as represented by lambda, one of the Greek alphabet, and lambda is exactly the differences between the two consecutive trough and two consecutive crests. This is called as crest. This is lambda, and between two trough also this is lambda, right? Length of a wave. We have another thing, and unit could be unit, usually it is meter, but in terms of atom and atomic terms, we take it picometer as 10 to the power minus 12 meter, angstrom 10 to the power minus 10, and nanometer is 10 to the power minus 9 meter. The next is wave number. Why are people shouting here? Yes. Then we have wave number, inverse of the lambda. So nu can be written down, nu bar is equals to 1 upon lambda, and this is exactly how many waves can fit in 1 unit length. And let's say if it is in meter, then in 1 meter how many number of waves can come. So this is equals to 1 upon lambda, and lambda should be taken in meter, then we'll be getting our answer in meter inverse per meter. Then we have speed. What is speed? Distance traveled by a wave per unit time. Jar, am I getting some disturbances? Jar, am I getting some disturbances? Yeah. So guys, we have this speed then, and speed is distance traveled per unit time, and we know that 1 upon t, that is per unit time, is your frequency. So frequency multiply lambda becomes your speed. C is equals to nu into lambda. So this is very important, and C is equals to 3 into 10 to the power 8 meter per second for all electromagnetic radiations. Then we have amplitude. Amplitude is the height of the crest or depth of the trough. So this is amplitude, and amplitude depends upon what parameter we are measuring. If we are measuring in the terms of length, then it will become unit in meter. Here is a question. Total horizontal distance covered by the given wave will be what? So guys, see, from here reaching to here, this is called as 1 lambda. Then this will become another lambda, and this has become overall 2 lambda. A is the correct answer. We have next question with us. that the wavelength of a 400 nanometer, so nanometer will be 400 into 10 to the power 400 10 to the power minus 9 meter is the wavelength and does not correspond to, so frequency. So let's see if it has the frequency of this much or not. We have to identify which one is the incorrect option given out of here. So number 1A, let us find out the frequency. Frequency will become what? C by lambda. So C is what? 3 into 10 to the power 8 and lambda is 400 into 10 to the power minus 9. So this will become what? 30 by 4 into 10 to the power minus positive 14. 17, 3 out of. So this is I guess 7.5 into 10 to the power 14 hertz, which is correct. Now talking about the wave number. Wave number is what? Wave number is nu bar 1 by lambda. So 1 by lambda will become what? 1 upon 400 into 10 to the power 9. So this will be definitely 1000 by 400 is 2.5 and 1000 is like 3 zeros have to be removed, 10 to the power 6. This is absolutely correct. Meter inverse, meter inverse. Then we have C option here. C option says that velocity for all EMW, this is EMW, AMR, so all EMW will be 3 into 10 to the power 8 meter per second, 10 to the power 8 meter second inverse. And the final thing is D. The D says that lambda will be equal to 40 angstrom. So lambda is right now we are having it as 400 into 10 to the power minus 9 meter. So guys, do one thing, just multiply this whole and divide it by a whole by 10. So if you divide it by 10, it will become 10 to the minus 10. Multiplication will become 4000 into 10 to the power minus 10 meter. So this will be recalled as 4000 angstrom, not 40. So this is the correct answer. This is actually incorrect option and this will be the correct answer of the question. So which of the following does not correspond will be 40 angstrom will not correspond to the given data. Next we have dual nature of light or dual nature of electromagnetic radiations. So guys, the dual nature means one of them could be wave nature, which is pretty much visible. We all know light reaches towards, light comes to us in the form of wave, and the wave nature, or we also call it the continuous nature. The continuous nature of light is explained by reflection. These are the phenomena that explain the wave nature of the light: reflection, refraction, diffraction, and then we have interference. So this interference is very important. Constructive interference, destructive interference comes in wide use of our chemistry. So refraction, reflection, diffraction, and then we have interference. Then comes wave nature. Apart from wave nature, we have one more nature called as particle nature. Particle nature of light, like we'll treat light as a particle. Light particles will be there called as photons. So particle nature, or we can say quantized nature or discontinuous nature. Discontinuous nature. So what is the particle or discontinuous nature? So under this, there are some mechanism that comes, or the phenomena that we'll understand. One of them is called as black body radiation. Black body radiation. Then we have Planck's quantum theory. And then photoelectric effect. this whole makes us to understand the particle or discontinuous nature of the light also. But we usually think that light might be continuous in nature, and wave nature is pretty much observable. Reflection, refraction, difference, diffraction, interference. This is something which we have studied till here, and even in the small standards in 10th standard, 9th standard also. Right now we'll come to know the particle nature, and the particle nature is explained by, first of very all, black body radiation. So what is the meaning of a black body? Black body is an ideal body which we are assuming that can absorb and can radiate out all forms of energies of all the wavelengths and all the frequencies, called as an ideal black body. So take an example. Let's say we are having an iron ball, Dragon Ball Z. So this is not Dragon Ball, this is iron ball. And now we are heating this apparatus using a Bunsen burner, let's say, and temperature is keeping on increasing. This is on fire now. So on heating it, what does it do? It first of all accepts so many things, and then it radiates out. The radiation which are coming out of it will be discrete radiations of different wavelengths and energy. So basically what we are getting is discrete wavelengths, and that indicates that we are having non-continuous energies coming out of it. They are discrete and they are different forms of energies with different wavelengths and frequency. And this is how it works, starting with it is red in color, then becomes whitish in color, and then reaches to the sky blue in color. So this is what the variation comes when you keep on increasing the temperature from 1000 Kelvin to up to 10,000 Kelvin. So guys, this is a black body. Black body is an ideal body which emits and absorbs radiations of all frequencies, is called as a black body. The perfect example of a black body could be sun. Sun can accept all the radiations, sun can radiate out all the radiations. The example could be the sun. Perfect example of black body. Black body doesn't look black in color. Black is just a number. Black is just a concept there. It's not even the color of a body. Exact frequency or wavelength distributed by emitted radiation from black body depends only upon its temperature. So let's have a question on black body radiation. We just studied now. As the temperature of iron rod increases, its color changes from what to what? As the temperature of iron rod increases, its color changes from red to white to blue. I think A is correct. Perfect. Now I'll explain you what is our Planck's quantum theory. So guys, as per the Planck's theory, these are the particles which we are receiving of light, and these are particles, and these are the waves explained by Maxwell. So now we'll understand the Planck's quantum theory. We already know about the wave nature, reflection, refraction and all. This is something which we already know about it. The only thing that we do not know is your quantum theory and the particle nature of the light. So let us start particle nature of the light from this Planck's quantum theory. So Max Planck was the name of a scientist. In 1900, he proposed that the radiations also have their particle nature, and here are the radiations. They travel in the form of energy packets. These packets are called as quantum, and plural of that is called as quanta, but plural is called as quanta. Then we have the energy of a single quantum is directly proportional to the frequency of the radiation. That is, E is directly proportional to nu, and H is the proportionality constant called as Planck's constant. The value must be known to all of us. It is very important. I'm marking star to it. 6.62 10 to the power minus 34. So let's say if I elaborate on it, or I go on expanding this formula. So energy of a photon is directly proportional to the frequency of a photon. We also know that E will become h nu. H is the proportionality constant called as Planck's constant. proportionality constant is equals to 6.63 10 to the power minus 6.626 into the power, I'll keep it 6.63 also, 10 to the power minus 34 joule simply second, not inverse, joule second, joule multiplied by second. So this is how you can elaborate this formula, that since nu into lambda was equals to C, so nu becomes equals to C by lambda, so this formula also becomes energy of photon is equals to hc by lambda. So this is inversely proportional to lambda and directly proportional to the frequency. Take formula in your mind, we'll move forward then. And those who haven't liked the session, do like the session immediately, everyone. Please like the session. Now we have the calculation of energy of the photon. So how you can calculate the energy of a photon? So we already know that hc by lambda is 1, and I'll give you some shortcuts to determine the formula. So this shortcut says that energy of photon, which was actually hc by lambda. So first of all, it was h nu. So h is pretty much known to us, 6.63 10 to the power minus 34 joule second. But if we write it, EP is equals to hc by lambda. So h is how much? 6.63 10 to the power minus 34 into c is 3 into 10 to the power 8 meter per second divided by lambda. On solving, it will give you a value of 2.25 into 10 to the power negative of 25 upon lambda. So approximately we can use this value, which is exactly a simpler version. So these are some formulas. Third could be, if you have to calculate out energy of photon in electron volts. So guys, what we have to do is energy in joules divided by 1.6 10 to the power minus 19 has to be done in order to find the value in electron volt. But I can give you a shortest way that energy of a photon in electron volt can be converted, can be done by 12400 upon lambda in angstrom, or 1240 divided by lambda in nanometer. This is also one of the formula that we can use. So see, one of the shortcut. There comes another important formula in order to convert the fourth one. Let's say if I want to calculate out the energy in kilojoule per mole, and from energy in electron volt can be anyhow calculated out using 12400 upon lambda. So if we have to find out kilojoule per mole, so the simple formula is there. You first multiply it by 1.6 to the power minus 19, it will become in joule, then divided by kilojoule, so it divided by 1000 and multiplied by 6.02 to the power 23. Anyways, the final outcome I can tell you, final outcome comes that energy in kilojoule per mole, energy in electron volt, this is for one atom, multiplied by 96. So that is another important term I have told you. These are some 4 formulas and shortcuts that you can apply, can implement anywhere you want. 96.5. Like this. So please guys, note it down, and believe me, these terms are highly important. So probably in my next section, when we'll be solving the PYQs related to this chapter and so many practice questions, then you realize that these formulas are highly important and very much convenient and convertible, because we have their shortcuts with us, we have their fast problem solving formula with us that will give us the answer even in lesser span of time. Then comes another term, that since we have derived this part till now, that whenever we require some charge, it will be an integral multiple of the charge of an electron. In the similar way, what we can say, that whenever we require some amount of energy, total energy, so this total energy will also be an integral multiple of the energy of one photon. So it will become n multiplied by E into P, where n is the number of photons or quanta and EP is the energy of photon. Are you guys getting it? Now I think it is the time we should start solving some questions first of all. There we have the first question. We have a question that calculate the energy in joules corresponding to the light of wavelength 45 nanometer, and the Planck's constant is this much and C is given to us. It's very easy. We have been given in 45 nanometer. So I'll do one thing and calculate the energy, and in joule only. So E in joules will be equals to 2.25 into 10 to the power minus 25 divided by this lambda, which is 45 into 10 to the power minus 9. So you can solve this equation. It will be like 225 divided by 45 into 10 to the power. See, if I am putting it like, it will become 27. Then 27 minus 9. No. 27 minus 9 will become what? 18. So minus 18. So this will be like 4.42 into 10 to the power minus 18. The only correct option is this, D. D is the correct answer. Next question is that the value of Planck's constant is this and the speed of light is this, we all know. Okay, nanometer per second we have given. Which value is closest to the wavelength in nanometer of the light with frequency 10 to the power 16 to 10 to the power 15. So guys, we have been given up with the frequency here. Nu is given as 6 into 10 to the power 15 hertz SI unit, and the value wavelength in nanometer we have to find out wavelength. So wavelength will become what? Lambda is equals to C by nu, because you know C is equals to speed is equals to lambda into frequency. So simply solve it. 3 into 10 to the power 17 nanometer second inverse divided by 6 into 10 to the power 15 second inverse. So second inverse will be cancelled out. Everything will come up in nanometer only, and I think the correct answer is 300 by 6 is 50. So very simple questions actually usually come in your exam, and when I'll come in next basically lecture, I'll bring some PYQs also, so that you will be highly confident about solving the question. But till then you should learn how to apply the concept, you should learn the formulas, and then try solve the questions only until then. Or whatever the question I'm giving you as homework, you should do that question only as of now. So after successfully completing one of the very important part of this chapter called as Planck's quantum theory, now we have reached to photoelectric effect given by Sir Albert Einstein. This effect says that whenever light strikes to the metal surface, the surface electrons of this metal come out of the their atomic level, and then they becomes easy to move somewhere, and movement of electron causes photoelectric current. That is what the mechanism of this entire photoelectric cell is. So what is it? Let us learn the phenomenon of the ejection of electron from the certain metal like potassium, rubidium, cesium, etc., which will be having lesser ionization enthalpy. On exposing them to the light is called as photoelectric effect. It's very simple. That's the definition of photoelectric effect. Then comes work function. Work function, we have work function. So guys, what is work function? So work function is represented by phi, and phi is the, it's actually property, it's not a property of incident photon, but actually it is a property of, metals, individual metals. It's the minimum energy of incident photon It's the minimum energy of incident photon required to just eject out an electron out of metal surface with no kinetic energy. Like there is no kinetic energy associated with the electron. It is only coming out of the metal surface. This type of energy, this minimum amount of energy of the photon will be called as work function. But again, it's not a property of a photon, it's a property of the metal. That metal at least requires this much amount of energy to eject out its electron. So what I can say, that energy of incident photon, let us suppose, is lesser than the phi, then no photoelectric effect. If EP is equals to phi, then photoelectron will come out with no kinetic energy, just came out. And if EP is greater than phi, then photoelectron with kinetic energy you will be getting. So now if I ask you how much is this kinetic energy, so you can do one thing, sir, that kinetic energy maximum, this is actually the remaining amount of energy, carried by the photon, carried by the photoelectron after removal from metal surface. तो क्या करेंगे? Kinetic energy maximum. So we are assuming that all the energies remaining is converting back into kinetic energy. That's why we are saying kinetic energy maximum. So guys, kinetic energy maximum will become equal to energy of the incident photon minus the work function, which is phi. This is the formula. Okay, clear till here? Hopefully. Then we have threshold frequency versus threshold wavelength. So guys, threshold frequency. So basically this is somewhere associated with the work function only. So what I can say, that work function phi is equals to h into nu naught, and this nu naught is exactly the threshold frequency. So what I can say, that since it was the minimum amount of energy required, it will become minimum frequency of incident photon required, of an incident photon required to just eject out an electron of metal surface. With zero kinetic energy or no kinetic energy. And we all know how is it connected? Phi is equals to h. Similar way, we can say that phi can also be written down as phi is equals to hc by lambda naught. And since it is inversely proportional and phi is the minimum amount of energy which is required to eject out the electron, lambda naught will become maximum, because if lambda is maximum, this thing will become minimum. So we'll simply write, instead of minimum, we'll write maximum wavelength of incident photon, required to just eject out an electron from metal surface with no kinetic energy. Okay, so phi is equals to hc by lambda naught, and phi also equals to h nu naught. So the respective formulas can also be become what? So we had this formula that E kinetic energy maximum was equals to energy of photon minus phi first, then we can say kinetic energy maximum will be equals to h into nu minus h nu naught, and we can simply say h of nu into nu minus nu naught, another formula. And similarly, kinetic energy maximum can also be written down in the terms of lambda as hc by lambda minus hc by lambda naught. So you take hc common, so it will become 1 by lambda minus 1 by lambda naught. These are some set of formulas that we will use throughout this particular concept, and we will also solve some numericals on this. So guys, those who haven't liked the session, do like it on priority right now. So that is how we can find out the value of the energies, kinetic energy maximum. Now another term comes that number of photoelectron ejected versus intensity. So it's very simple guys, that so as many as the number of electrons ejected is directly proportional to the intensity of the light. Intensity is the number of photons we are sending. Higher is the number of photon, higher will be the number of ejected photoelectron. So we will simply say that it has been assumed that the number of since one photon strikes only one electron at a time, thus higher is the number of photons. You all understand what we are talking about is the intensity. Higher is the photoelectric current. Higher is the photoelectron are coming out of the metal surface, higher will be the photoelectric current. It's that simple. So this is electric current I versus light intensity I. Why are I? And it's a straight line graph. Then Einstein explanation, okay, it's okay, that's simple a theory only, just skip it and move forward. Then comes one of the graph of maximum kinetic energy versus incident radiation. Okay, so let us suppose there is one graph. Some graphical basically interpretation will do. Some important graphs. Here are some important graphs. So see, first graph is kinetic energy maximum versus incident energy of photon. Okay, so the graph will be, we know that, let us suppose this is the enthalpy, this is the kinetic energy maximum, and let us suppose this is the energy of photon. So we know until or unless the energy becomes phi, it will not eject out. So the x-axis will become what? This is the phi value, and this is will your kinetic energy maximum. First graph. Number 2 is kinetic energy maximum versus frequency of incident photon. So check it out. This is nu, and nu will not release any until unless that nu becomes equals to nu naught. This is your nu naught, and this is your kinetic energy maximum. This is how the graph works. And then could be the third one. Kinetic energy maximum versus intensity of light. Now is something that we have to take in our account, that how come kinetic energy is dependent upon intensity. Higher is the intensity, higher was the electric current, but we are talking about kinetic energy which belongs to one single photoelectron only. So how can we do it? See, this is your kinetic energy of one photon or one photoelectron. Now let the other photons come, other photoelectrons may participate, but this photoelectron will have the same kinetic energy. So this is how this is your intensity of light. So that is how this works. It is independent of, kinetic energy is independent. So I'll simply say note kinetic energy maximum of a photoelectron is independent of the intensity of light or the number of photons you are sending. It is not dependent of that, because that is the data which belongs to single photoelectron. So let that be more number of photoelectron this time, but kinetic energy of one will not change. Great. Next. So guys, there is one more thing that I want to tell you, is called as stopping potential. And the significance of stopping potential is, so let us suppose your electron is now running with a maximum kinetic energy possessed by itself, and we have to stop it. So what you will do, you will apply a negative charge potential, let's say negative and positive is there, to stop it, and let's say potential difference is V. V naught is the stopping potential. So guys, kinetic energy maximum should be equals to the work done to stop electron. Work done to stop electron is equals to charge into potential. The charge is how much? Electron is E into charge, and V naught is the potential difference, and it is equals to the kinetic energy maximum. So if you can manage this equation, you can also find using this equation that V naught is the stopping potential, the potential difference which is required to stop the movement of that electron. That's it. Here we have some basic questions. We have good plenty of questions here also, but we'll come with a big session including all the PYQs from 2002 to 2024. There we'll discuss all the questions. So my suggestion to every one of you is simply write down the chapter with me, and then you can also download our notes and you can complete your notes from your end. And at least those people who are preparing for 2026, notes are highly important for them, so that they can organize their notes. They must know what was the flow of the chapter, and then knowing the complete mind map about this chapter. It's very important. And right after that, after completing all the formula part or learning everything theoretically, some solved problems, some of the homework I gave you, you come in the next session. We'll be doing the PYQs of like past 2002 to 2024, which is a like good exercise session we'll be having. Next, here is a question. Here is like assertion that electrons are ejected from a certain metal where either blue light or violet light can strike. Now, this good part, that a metal can eject out electron from blue light, which has a lesser energy. So you must know that the energy of blue is lesser than the energy of violet. Then another reason is that the electrons in the first metal require less energy. So in however, in violet light causes ejection in the second. Okay, we got it. So guys, you will already conclude that blue and violet both can eject out from first metal, and only violet can eject out from second metal. So we can say that phi 1 should be lesser than phi 2. That is why blue and violet both can eject out electron from first metal, and from second only violet or with higher energy can be explained. So I think this is a good answer along with the good explanation also. So just read it out and give the correct answer. And those who haven't liked the session, do like the session ASAP. A is the correct answer. Next, the number of photoelectrons emitted depends upon what? The number of photoelectrons emitted, it depends upon number of photoelectrons, intensity, yes. Number of photoelectron depends upon the intensity. Frequency, no, it doesn't depend, because one photon can strike to one photoelectron only, one electron only. So whatever the frequency you are sending, number of the photoelectron will not depend upon that. So does the both will not be the correct answer. I think A should be the correct answer. Next is, in photoelectron emission, the energy of emitted electron is either it is greater than incident photon, same as the incident photon, smaller than the incident photon, proportional to the intensity of photon. The photoelectron emission, the energy should be emitted is always lesser. See, actually the incident photon is EP. This is having phi plus the energy of the photoelectron. So what I'm saying is that energy of the ejected photoelectron, and these all terms are actually positive, will definitely be lesser than the energy of incident photon. The correct answer should be smaller than incident photon. Hopefully you are getting it. One numerical here, in order to just get into the idea that how do we solve the numericals come into questions in examinations. Especially copper metal has a work function 4.8 electron volt. Anyways, we can deal in electron volt also. We know some of the formulas and can show a photoelectric effect with wavelength of photon. This. So guys, we have been given with photo work function is given us. Phi is equals to 4.8 electron volt. So using this data, you can calculate out delta naught. Delta naught, how can you find out? Lambda naught. So phi is equals to hc by lambda naught. So lambda naught will be equals to what? Or you can also say that we can also write it 12400 upon, if it is in electron volt, then this could become lambda naught in angstrom. Remember this formula. So it will become 12400 divided by, how much is it? 4.8. So lambda naught in angstrom will be equals to 12400 by 4.8. If you solve this equation, I guess you will get some value related to 48. Let's say if I take it 50. So I'm assuming it like 5. So 5 2 ni 5 2 ja 10. Nearly I got this value nearby to 2500 angstrom. So guys, you all know photoelectric effect works only if energy of photon is greater than energy of phi, and lambda should be lesser than lambda naught, because higher is the lambda, lesser is the energy. So lambda should be lesser. Now where can you find lesser than 2500 angstrom? Not this, not this, not this. Only correct option is C. So that's how we do. So guys, like the session, everybody. Do like the session immediately. So in half an hour, we'll be having a lunch break. Sorry, a dinner break. Lunch is already done. We'll have a dinner break of some half an hour or like 20 minutes. And then I'll come back and we'll finish this whole chapter. Don't worry. So now, until then, I think I should finish complete Bohr's atomic model. So guys, you already have known about it. You all are now comfortable in Bohr. So what did Bohr do? So Bohr done the study about all the parameters of electromagnetic waves, their particles and everything. And now he has come up with some solid proof with him, and then starts the postulates of Bohr atomic model. Bohr says that model is applicable to only a single electron species like hydrogen, helium, lithium 2+, because he didn't take into account of the interaction between two electrons. The only interaction with electron was with the nucleus. That was an attractive interaction. Then the electron in hydrogen can move in the circular paths around the nucleus, called as energy states or fixed energy states, or also called as allowed energy states or stationary state. So these states are named in this way, like n is equals to 1. We say first orbit, we say it first orbit, and he gave it name as K shell, capital K shell. We have agar n is equals to 2, this becomes second orbit, where it becomes KL, L shell. N is equals to 3, we have third orbit, M shell. And so on. So this is what he defined, and he named all the shells, orbits accordingly. Then comes an electron. This was the drawback of Rutherford, that an electron can radiate out energy and can collapse in the nucleus earlier, old theory. But new theory says that it will not do so, because the path itself are the energy barrier, energy packets are the energy paths. So an electron neither releases nor accepts the energy and doesn't radiate out the energy, because the path are called as energy states or energy paths. So these are some postulates of Bohr, that the angular momentum of an electron in the stationary state can be expressed as this. So guys, learn it. It's a very important equation we'll be getting, that angular momentum, linear momentum is mv multiplied by r becomes angular momentum, is n, yani integrate multiplier of h upon 2 pi. That can also be written down as n into h cross. H cross is exactly equals to h upon 2 pi. Thus, an electron can move only into those orbits where angular momentum will be nth multiplier of integral multiplier h upon 2 pi. We can also say that angular momentum is quantized in an atom, or not just angular momentum, all the properties related to the radius, velocity and position of an electron, everything is quantized in the Bohr's atomic model, because Bohr simply said that you cannot find electron everywhere. Electron can be present only into those orbits or states where the angular momentum is there. Orbit angular momentum is nth integral multiple of h upon 2 pi. So just take this thing in idea and we'll move forward. Okay guys, now coming to the next. So guys, he also said that the energy paths are made in such a way that if we keep on increasing, or if we keep on going from nucleus to the next orbits, the energy keeps on increasing, and this increased energy, that's why requires energy to an electron if electron wants to jump from lower to higher. He called these jumps as transition, that if it is going if an electron does higher transition going from lower state to higher, then it needs to accept the energy in the forms of electromagnetic radiation, h nu, Planck's photons energy. And if it jumps from higher to lower one and it makes a transition in this higher to lower, then it will radiate out the same amount of energy. That is what it said. And the process of going from lower to higher called as excitation. The process of coming higher to lower is called as de-excitation. It's as simple as that. Not so much of the things. Keep it simple. Keep it simply theoretical. So the postulate is pretty easy, that whenever an electron falls from E2 to E1, and let it be anything, might be higher or lesser, then the energy of photon which it radiates out or it requires will be energy of photon, and it will always be taken as positive. So whatever you are doing, you are exciting it or de-exciting it, you always need to take the energy into positive, because if it is excitation, then this amount of energy will be taken by the electron, and if it is a de-excitation where from higher state to lower state an electron is jumping, then it will become what? De-excitation, and E photon will also be negative. That is amount of energy that will be radiated out by the electron. We till now have gone through simple theoretical explanation of Bohr's theory, which was pretty much familiar with the Rutherford only. But what made Neil Bohr more basically successful, that was the mathematical model. His mathematical calculations matched with the upcoming Rydberg's experiment also, that was done for the hydrogen emission spectra, and they all matched, and that's why it became a very popular thing for Bohr and very successful thing for the Bohr. Now let us start Bohr's atomic model in mathematical calculation. So we need to take two important things in account. These are mathematical expressions. The number one equation says that angular momentum is the integral multiple of h upon 2 pi. So one equation is mvr is equals to nh upon 2 pi. This is the first equation. The another one is centrifugal force is equals to attractive force. So centrifugal force is what? Electrostatic force is k q1 q2 by r square. So k q1 is how much? Ze. How much is the force of electron? E. this is r square. I'm just taking the magnitude because I know force is a vector quantity and they two are operating into different direction. In that way, F1 plus F2 should be equals to 0. F2 becomes negative of F1, but I'll simply write the magnitude part. It's very easy. We have to understand the concept rather than unnecessarily getting confused in the single sign and anything. No, we won't get confused. The magnitudes are equal and opposite to each other. So centrifugal force is what? mv square by r. So guys, this is how 1 r will be directed here, and you can say that mv square will be equals to kz e square by r. So now we have two equations with us, and plenty of, like, a few unknowns are here, v and r. So you can calculate the value of velocity. Come here. So we'll find out radius first of all. So what I can see, if I want to find out the radius, just simply do one thing. Take velocity and put it over there. So from equation 1, from equation number 1, we get velocity is equals to, so mvr is equals to nh upon 2 pi. mvr is equals to nh upon 2 pi. So it will become nh upon 2 pi. So mvr into m into r. This is your velocity. And then put in equation 2. Put in equation 2. What was the equation number 2 there? That kz e square is equals to mv square is equals to kz e square by r. So guys, simply put this value, m into n square h square upon, just take the square, 4 pi square m square, and then r square will be equals to kz e square by r. Just simply deduct one r from here and one m from here. So that's why you will be getting finally that radius will be equals to n square h square upon 4 pi square m kz e square. That is the value of r that we do not have to learn. We are not supposed to learn this value down, but after solving it, see, everything is given to you. N and z are unknown only. These are the variables which we can be decided by what thing we are taking. For first shell n is 1, second shell n becomes 2, third shell n becomes 3, like that. Z for hydrogen, it will be 1, helium plus it will be 2, lithium 2 plus it will be 3, like that. N and z will be known. Then we already know that pi is equals to 22 by 7. We know E is equals to 1.6 into 10 to the power minus 19 coulomb. We also know that mass of an electron will be 9.1 10 to the power minus 31 kg. And K is also equals to 9 into 10 to the power 9, which is electrostatic constant. Just simply learn it. If you put all these value down over here, you will get R as final option, 0.529. N square upon Z, because N and Z are the unknown and variable parameters, and that is coming in angstrom. Now learn only this. Only this has to be learned. Only this. Learn only this. So take this idea, take this value in your mind, that radius of nth orbit is equals to 0.529 n square by Z. How is it derived? Only using the two equations that are given to us. I hope this is absolutely clear to all of you. And even if it is not, I will make it clear. That's my promise. Now let us derive the velocity. So we know that the velocity of electron in nth orbit. Velocity of an electron in nth orbit. We already got one equation, that velocity is equals to mvr is equals to nh upon 2 pi. So it became nh upon 2 pi r into m. So guys, just put the value of R is equals to n square h square 4 pi square m kz e square over here. Then you will be getting the value of V is equals to nh upon, so this whole will go up 2 pi, sorry, not this one, this will go here, 4 pi square m kz e square, and down here comes n square h square, and also with 2 pi m. So guys, if you solve this equation, there is anyhow you will be getting the value. But anyways, the velocity from here will come up as, so nh upon 2 pi r m. M was already down there, and one more m has come. So velocity will become what? NH will be cancelled out. 4 pi will be cancelled out. It will become simply 2 pi. Okay, m 4 pi square m. Mm will be cancelled out, I guess. So anyways, we will be getting velocity as 2 pi kz. 2 pi, because this is cancelled out, 2 pi, 4 pi square upon 2 pi is 2 pi. Kz e square upon nh. This is what we got it over here, and on solving or putting all the values, this will give you a final velocity that we have to learn is 2.18 into 10 to the power 6 z by n meter per second. So this is what you have to learn. What is it directly proportional to? So velocity is directly proportional to what? Z by n. This is very important parameter. Similarly, over here, radius was directly proportional to n square by z. This was very, very important, crucial one. This information will be very much useful. Then we have the last derivation going for calculations of energy. Calculation of energy. How do you do the calculations of energy? So guys, the one thing is very simple here, that kinetic energy will be what? We know that potential energy is how much? So that was kz e square by r, kq and q2 by r, and potential should be negative because it's an interactional energy. Potassium, this will be k. How much is q1? Q1 was ze, q2 is the charge of electron minus e upon r, so it will become what? Negative kz e square by r. This is the potential energy. Equation number 1. Now let us come to the kinetic energy. How much is the kinetic energy, by the way, of any electron in nth shell? Kinetic energy was half mv square. And you know what is the how much was this velocity we got? This is the velocity, 2 pi kz e square upon nh. 2 pi kz e square upon nh. Okay. We can also do one thing. Kz square, and see, we already know that mv square by r. We already knew that mv square by r was equals to k q1 q2 by, what was that yaar? mv square by r was equals to k q1 q2 by r square. So simply you can find out the value of mv square. So kinetic energy will be coming up as half of kze square by r. So this is one equation, kinetic energy. Now you observe them, everybody. First equation and second equation, what you are getting is that mode of kinetic energy is equals to mode of potential energy divided by 2, isn't it? So you will be getting total energy. Total energy is equals to kinetic energy plus potential energy, and we already know this is the second time of this. It will come up as negative of kze square by 2r. Negative of kz square by 2r. Now what you'll do, let's say if I have to find out the total energy only, total energy is equals to negative ka kze square by 2r, and if I put r is equals to n square h square upon 4 pi square m kze square, if you put it over there, then this total energy becomes how much? Minus kze square into 4 pi square m kze square divided by n square h square, and that to 2. So I think this will become how much? Total energy is how much? 2 negative of 2k square z square e raised to power 4 kze square m and pi square m divided by n square h square. So on solving this value, guys, on solving, there's a complicated one version that we don't need to learn. On solving, we'll simply get total energy equals to negative of 13.6, or I forgot the value here. Negative of let me find out in terms of joule first of all. Some energy it was like 2.7 in 221.76 19. So I'll say 2.1. So we'll simply write 18 only. So it's simply negative 2.18 into 10 to the power minus 18 z square by n square. This is joule per atom, or if you divide it divided by E, then it also become negative 13.6 z square by n square electron volt per atom. Guys, learn it immediately. Don't waste the time with a negative sign. Learn it immediately. These two values are highly important. चलो भाई, हो गया सलाम रोकी भाई. Yes, let's try some questions then. Now let's try some questions then, and then the major solving part will be conducted by me in my next episode, next session. But till now, just take the idea whatever we have learned till here. The difference in the angular momentum associated with the electron, how much is the, so guys, we all know for nth shell angular momentum is nh upon 2 pi. successive it is asking. Let's say if for n plus 1, n plus 1th shell, it will become what? nh upon 2 pi, so n plus 1 h upon 2 pi. So if you calculate out the delta of angular momentum, it will be coming up as upon h upon 2 pi. nh upon 2 pi will be cancelled out, h upon 2 pi will be remaining. Answer should be h upon 2 pi, B. It should be, this is incorrect, I remember, B is correct. Next question, radius of hydrogen atom. Now this kind of questions are sometimes asked in JEE, and you will see plenty of PYQs in similar pattern. There are plenty of questions in similar pattern. The question says that the radius of hydrogen atom in ground state is 0.53. The radius of lithium will be what? So guys, I'm giving you an idea, just better you start solving it by your own. Allow me to take a call and then I'll complete this question. So do one thing, that since radius is direct proportional to n square by z, so r2 by r1 will be equals to n2 square by n1 square into z1 by z2. So just apply this formula and you'll get the answer. You try it by your own. Allow me a second and I'll come back and rejoin you. So hi guys, I'm back and let's see who has solved this question. And seems like nobody has solved this question. Not a problem, not a problem at all. So what we'll do? Radius is direct proportional to n square by z, and this is the we have to apply. So what it will give me that after like writing this whole equation, you can see that radius of we have to calculate the radius of lithium ion in a similar radius of hydrogen ion ground state is this, and radius of so radius of lithium has to calculate. So radius of Li2 plus 4n is equals to 1 we have to find out upon radius of hydrogen n is equals to 1 we have given up with, which is equals to what is the z for lithium, sorry, n is 1 only, 1 square by atomic number is hydrogen helium lithium 3, 1 square by 1. So this will be simply radius of Li2 plus will be equals to radius of hydrogen is 0.53 divided by 3. So how much is the answer? 0.17 angstrom. See how easy was this question. And these similar questions have been asked previously very frequently. Sir, I have solved. Android Gaming said I have solved, but you didn't submit your answer, and that's why I thought that you were not able to solve. Anyways, mention answer also. So that's how we do it. Let us take one more example of the same, and I think you should take it in the homework. You should take it in the homework. Okay, whenever it is saying excited state, the first excited state is equals to n plus 1, where n is the nth excited. Wherever it says that nth excited state, so let's say now it is saying first excited state, so it is actually talking about n equals to 2, because first is excited state and plus 1 we have to apply. Then the value of n of the velocity is, so guys, we know velocity is directly proportional to z by n. If n increases, velocity decreases. So electron moves more faster closer to nucleus rather than staying apart or far from the nucleus. Here is another question, that speed of electron. Similar concept will be used, very similar concept will be used like this, that velocity is direct proportional to z by n. So v2 by v1 will be equals to z2 by z1 into n1 by n2. This is what we have to use. So check it out. If the speed of electron in second Bohr orbit of helium plus is v, then the speed of first Bohr of hydrogen will be what? So velocity for hydrogen n is equals to 1 will be equals to upon velocity of helium, which is given to us, plus, and n is equals to given is second orbit 2. So will be equals to z1 by 2, z1 by z2, no, z is incorrect here, 1 over 2, okay, and speed will be n2 by n1. So n is 2 here, so 2 will come over here and 1 will come here. I think it will be the same only, v only is the correct answer, v. Can I check it out? Oh great, it's v only. नमन मिश्रा, हाय यार, नाम ले लो, नमन स्टे हैप्पी, ले लिया नाम, नमन की जय हो, नमन को शत शत नमन. चलिए guys, now we have come to the Bohr's atomic model and we will be talking about the energy level diagram. What is the meaning of energy level diagram? Let me take you to energy level diagram once. Guys, this is the nucleus. Let us suppose this is your n is equals to 1. This is your n is equals to 2, n is equals to 3, n is equals to 4, and blah blah blah, and so on we reach n is equals to infinity. So this is, let us suppose, an atomic model with us, and let it be hydrogen itself or anyone is fine. So guys, we all know that energy of first shell will be what? Minus 13.6 z square by n square will be equals to minus 13.6 electron volt. Then E2 will become what? Minus 13.6 into Z is 1, that is for hydrogen, and that 2 I'm talking about for hydrogen atom. What we are talking about, model for hydrogen atom. So E2 will become what? Divided by 4. This thing divided by 4 will be minus का 3.4 electron volt. Then what will be the E3 divided by 9? This will be minus 1.85 electron volt. Then E4 will be 1.5 electron volt. 1.5 electron volt, and this is minus 0.85 electron volt. And then E5 will be 0.5. And at infinity, see infinity, minus 13.6 z square upon infinity square will become what? Something upon infinity is 0 itself. Then it will be E infinity is equals to 0. So guys, this is the beauty that you will understand, that when we leave the nucleus and move away from the nucleus, the energy keeps on increasing in magnitude, specifically with the sign C. Minus 13.6, minus 3.4, minus 1.4, and the maximum energy can be attained at the infinity, which is equals to what? 0. Wow. So maximum energy of an electron can become 0 when it is isolated from the atom, and minimum energy can be in the most stable state, ground state, stationary state, or called as the n equals to 1, where it will be having minus 13.6 electron volt per atom as energy. You also must know what is the differences of the energy. Talking about the differences, you can find out delta E1. You can find out delta E1, that is E2 minus E1, but it should always be positive. So delta E1 will be equals to, if somebody wants to jump from here to here, it has to accept this amount of energy. What is the difference coming out of it? 10.2 electron volt. If you talk about this delta E2, this will be how much? Minus 1.5, 15 में से 34, minus 1.9 electron volt. And you are seeing that this gap is getting reduced when we move away from the nucleus. The gap is getting reduced. So let's say if the differences between the 85 and 15 has to be calculated. So how much would it be? 0.65 electron volt, and so on. So these are some important terms that we studied, and this is the energy diagram for hydrogen atom we made. Now we'll move forward. We have excitation energy of electron, that is what I told you. Ground state is some energy, the state where an electron can neither lose an electron nor gain an electron neither gains energy nor loses energy, is called as ground state. Usually for hydrogen and hydrogen like species, the ground state will be n is equals to 1. Usually it will be n equals to 1 for hydrogen, helium plus, lithium 2 plus, beryllium 3 plus, and on. First excited state is equals to n is equals to 2. Second excited is equals to n is equals to 3. That always add 1 to the name excited. Second means sec 2 plus 1. First means 1 plus 1, like that. Some questions. So when an electron drops from higher to lower, it radiates out energy, emits the energy. Very simple question. The energy of an electron in nth both orbit of hydrogen atom is, so it is 13.6 z square by n square. Hydrogen z take 1, it will simply become this. So now we have ionization energy. So before reaching to ionization energy, let me just take you to one simple idea, that let us suppose you right now are into N1 and here is your electron, and you want to take your electron to, let's say this is your N2. Let it be so many shells have been passed. This is not the next n, this is not N1 plus n plus 1, N1 plus 1, this is not N1 plus 1, this could be anything. So let's say there are like plenty of states in between, and we have reached to there. So how much amount of energy is required to bring this electron over there? So definitely this electron will accept some energy in the forms of h nu, energy of photon. So this energy of photon is equals to h nu is equals to delta of E, and delta of E is E2 minus E1. So what is the value of E2? Minus 13.6 z square upon N2 square minus 13.6 z square upon N1 square. So guys, ultimately remember this point, that it will come up as 13.6 z square 1 by N1 square minus 1 by N2 square, in order to keep this value as positive. This is the electron volt per atom, and we use this formula very generally. Everywhere we can put this formula. Let it be the case of ionization, let it be the case of excitation, let it be the case of binding energy. We can put this formula anywhere we want. So let's see. We have first, here is the ionization energy of an electron in Bohr's atom. Ionization energy of an electron in Bohr's atom is how much? So guys, here N1 is your 1, which is called as ground state, and N2, where we have to make it to reach, is infinity. So this is your for ionization. So what will be the formula? We already know this formula, that delta E will be equals to E2 minus E1. So 13.6 Z square 1 by N1 square minus 1 by N2 square. We already know that this will become 0 for N2 is infinity. This will become 1. The simple answer says 13.6 into Z square. Electron volt is the ionization enthalpy. See how easy we got it. Same thing can be applied if binding energy or separation energy has been asked. In the separation energy, sometimes we will take N1 is equals to some N, whatever the level is given, from where we have to remove the electron to. We are making the electron to reach to N2 is equals to infinity. Simply same formula. Delta of E will be equals to 13.6 into Z square 1 by N1. N1 is N square minus 1 by N2. Infinity square 1 by infinity square is 0. Simply answer comes 13.6 Z square upon N square electron volt. See how easy. So you need to be clear about your concepts. Once you are clear about one concept, you will get another very easily. This question is a JEE Advanced 2024 question. Everybody, whoever is watching, I am solving a 2024 JEE Advanced question. But believe me, this is no advanced level question to me and to all of you, and for those who have understood the concept. According to Bohr model, the highest kinetic energy is associated with electron in the. Which one of them is having highest kinetic energy? You all know kinetic energy. All the type of energies are directly proportional to Z square by N square. Let it be kinetic energy, let it be potential energy, let it be total energy. But total energy and potential energy can be negative. So this can create a lot of chaos, understanding the magnitude or with the sign or with the symbol. That's why they give this question in terms of kinetic, because kinetic is always positive. Farther you go from the nucleus, your kinetic energy reduces. So this will be directly proportional to this kinetic energy. Z for hydrogen is 1 and 1. 1 square upon 1 square. This is 1 by 1. We will simply write this is 1 by 1. This is direct proportional to Z is what? Helium, 4 by 1. Direct proportional to helium, second orbit, 4 by 4. That is 1. Direct proportional to lithium, second orbit. So hydrogen, helium, lithium, 9 by 4. Now can you check the maximum value? I think B is the correct answer. It would have not taken me, in fact, 5 seconds to solve this question. That is how easy question of JEE Advanced 2024 came this year. Then we have frequency and time period also, everybody. So I don't think whether we require to learn it too much about it, because let's say if we are first solving time period. T. You all know what is the meaning of time period? Distance upon speed. What is the distance traveled by an electron in one cycle? 2 pi r. What is the speed? V. So we can say simply time period is directly proportional to radius. Radius is what? N square by z. And what is velocity? Z by n. So this is time period directly proportional to n cube by z. Now using this data, you can find out time period of whatever it is asked and whatever it is given with. That's what we are doing in these questions. A directly proportional to B, A2 by A1 is equals to B2 by B1. Second thing could be your frequency. Not your frequency, means the frequency of an electron. How many rounds does it take in given time? Frequency nu. So nu is calculated by 1 by time period. Inverse of the time period. So the nu will be directly proportional to what? Z square by n cube. This is, I forgot to put Z square. So guys, using this information, you can find out whatever you want. And that's where we end with this concept of Bohr's theory. And now comes the drawbacks of Bohr theory. How did Bohr theory fail? Why couldn't it explain and other things? So failure of Bohr theory says that first of all, it fails to account for the finer lines that was observed when you went into very zoomed version of the lines. There were like every fine line was divided into two lines, and that is all because of the H2 molecule might have seen there. Or maybe this model is not also explained other than hydrogen. It was only defined for the single electronic species like hydrogen, helium plus, lithium 2 plus, like that. There are two things that you got to learn. I'm star marking these 2 points. The number one is splitting of the line occurs in electric field called as Stark effect, and splitting of lines in magnetic field in called as Zeeman effect. Now, what are these lines? I'll explain it right now, just after some time. But until then, just take this idea. It could not explain the ability of atoms to form the molecules by chemical bonding. And that's the achievement that many of the discrete energy levels matched with the calculations. It also gave us the correct transition of an electron one to another. Biggest achievement was the explanation of hydrogen spectrum by Rydberg was very much satisfactory with the results of Niels Bohr. So we'll come to that part, but before that, let's try some questions. So frequency is inversely proportional to n cube and directly proportional to z square. Zeeman effect is actually the effect because of the magnetic field. Where can you find magnetic field? A. So now we will come to the hydrogen emission spectra. So before coming to hydrogen emission spectra, let me just take you to till here. And those who haven't done it, do it immediately. We are now announcing a dinner break. So we have a 20-minute dinner break, and we will come and join soon. So those who would like us, like the session first. Hi guys, so I hope this was some healthy break for all of us, and hopefully you all have had your dinner, and now we'll continue and we'll try finishing this chapter within some hours or couple of hours very soon. So now let's come back to this topic. We are missing hydrogen emission spectra first. So let me go to hydrogen emission first. There we have it. So guys, okay, I'll give you the idea. How does this hydrogen emission spectra work? We first of all have this. So we have this cathode ray tube, the same exact cathode ray tube in which hydrogen gas is taken under low pressure and is connected to some high voltage source. Right after the discharging, so many of the hydrogen atoms acquire energy and then they reach to the higher levels and then they come back. The moment they come back, they lose out some energy. This is the lost energy. This is actually the emitted energy. This is your emitted energy or radiations. So these emitted energies are now passed through a lens. Lens is basically doing the part of to converge them. This converge are passing through this narrow slit which is called as collimator. The purpose of collimator is to make the lines straight, and then passing through prism. Prism makes this all like separated in order by their increasing order of their wavelength or their frequency in different portions. Now this is the screen or called as the photographic plate where we are recording everything. So now I will give you the simplest model of what we have studied. So this is called as n is equals to 1. This is your n is equals to 1 first shell of hydrogen atom, let's say. This is your n is equals to 2. This one is n is equals to 3. This is your n is equals to 4. N is equals to 5. This is n is equals to 6. And this one is, let's say, n is equals to infinity. Okay, 1, 2, 3, 4, 5, 6, infinity. We have reached to infinity. So now electrons are trying to come back. Electrons are trying to come back, and the moment they come back, they fall down to let's suppose they are falling down to n is equals to 1. First shell they are falling down. So if the excited electrons in hydrogen atom fall down directly to ground level, this is called as Lyman series. And the Lyman series falls in ultraviolet region. So basically all the energies which are emitted out of this Lyman series will belong to this, what we call it as Lyman series, ultraviolet region. Good. Now I'll take white because white is the visible color. So now let us suppose the electrons which were excited now falling down to n is equals to 2. The moment they fall down to n equals to 2, they will release out some energy. This energy is actually looks like visible. So this is visible region, and the name of this is Balmer series. BALMER, Balmer series. This is Balmer series radiations, and the color is actually visible. So you can have all the Balmer series passing through another prism, and then you will see this follows a Vibgyor. Then at third, We have lines now coming to the third shell like this. So all of these are called as infrared lines and they belong to, see, Lyman-Balmer-Paschen series, P-A-S-C-H-E-N, Paschen series. Then we have Lyman-Balmer-Paschen bracket series, and then we have Lyman-Balmer-Paschen bracket Fund Humphrey. It's too much, yeah. This is your Fund series, and this is your Humphrey series. So ultimately, whatever the red ones are there, they all belongs to infrared region. This is infrared, ठीक है ना? So Lyman, Balmer, Paschen, bracket, Fund, Humphrey, and majorly we have Balmer, which is visible, and all of the above one are infrared, and then they become far infrared. Here it is Lyman series belongs to visible region. So now this is what it is, the overall summary of N1 will be N1, 1, 2, 3, 4, 5, 6 respectively, and N2 will be a 1 which is right next, and then followed by other can be happened, and in fact it can go up to infinite. Then, so guys, there is a formula that we'll understand. This formula is the Rydberg's formula given by Rydberg himself, and there was another formula, if you remember, like I don't know if you remember it or not, I told you exactly like half an hour back that a formula was hc by lambda was equals to, what was the hc by lambda? Equals to minus 13.6, or let's say if I take it into 2.18 into 10 to the power minus 18, 1 by n1 square minus 1 by n2 square, and this was in terms of energy we said. So this is the formula that was from Bohr's. This was the Bohr's formula. Bohr's model, we derived this formula, and this formula what you are getting is derived from the Rydberg, and it is his experimental basically work. The mathematical derivation of his experimental work says this. This one is said by Bohr, and both of them belong to the same thing only, that if you even solve it and find out 1 by lambda, that is 2.18 by hc, that will also give you exactly the same value. But guys, I will give you an alternative to learn down this value. This value is exactly lambda, is lambda, no lambda, it is RH, which is Rydberg's constant for hydrogen. It is equals to 1.1 into 10 to the power 5 centimeter inverse, or you can also write RH is equals to 1.1 into 10 to the power 7 meter inverse. So that's how we do it. Both formulas are similar. For any kind of question, you can either opt for hydrogen, this Bohr's formula, or you can also opt for Rydberg's formula. Either way is fine. Now we have one important question that usually come in our examination, that what could be the shortest wavelength? For any kind of shortest wavelength, we are asking for the maximum energy. And for maximum energy, the N1 should be very least. Haven't we talked about this, that the gap keeps on decreasing while we go out of the, like away from the nucleus? The initial gap, like initial energy was something, then another energy was something. The first gap was around 10.2 electron volt, the second came was like 1.3 electron volt, and then it kept on decreasing only. That's what I'm saying is that if you pick the maximum energy, for maximum energy, see, shortest wavelength means maximum energy or maximum frequency, and also called as the limiting line of the series. Also called as what? Limiting line of series means N2 should be the maximum as possible, and the maximum one is infinite. And coming back to ground state, which is N1, the lowest possible value, then it will give you the maximum value of this change in energy. Similarly, if you have longest wavelength, means very least minimum energy, so this should be n1. First of all, n1 should be highest possible value, as in like if you keep on moving from the nucleus outwards, your delta of energy keeps on decreasing. So n2 should be maximum, like 1, 2, 3, 4, it should be 4. And then n2 should be right next to it, like 4 to 5. Then 5 to 4 will be the lowest amount of energy to be released. Guys, take this thing in your mind. And now I think we should start solving some problems right after knowing what is the number of line visible or like formed on the spectrogram. How can we identify it? So if you are falling from n2 to n1, then n2 minus n1 plus n2 minus n1 plus 1 by 2 is the total number of visible line that can be formed in this process. But if you are only falling with one atom, then only n2 minus n1 maximum number of lines can be formed. Check it out. So let's say we are right now jumping from n2 is equals to 5 to n1 is equals to 1. Let us suppose we are falling for n2 equals to 5 to n2 equals to 1, n1 equals to 1, and with a hydrogen sample. So this is 5, 4, 3, 2, 1. So this is n is equals to 1, 2, 3, 4, 5. Now see, maximum number of lines we are talking about. Bring every line to first, then that's it. Then to second, then to third, then to fourth. So guys, if you want to know the total number of lines, capital N will be equals to, I told you the formula, 5 minus 1 plus 1 by 2. How much does it come? This is 5 into 4, this is 10. And can you count it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the 10 lines. So let us say if I do the same exercise, but now with if I perform the same exercises, so what is the difference between these here? We right now here is hydrogen sample, like so many atoms are there, and here we are still n2 is equals to 5 to jumping to n1 is equals to 1, and let's suppose this is what we are having is hydrogen atom only, just one single hydrogen atom. Now what will happen? See, electron can fall at maximum of here, here, here and here. That's it. That's the maximum possibility. So capital N will be equals to N2 minus N1. Four is the correct answer. You can count it 1, 2, 3, 4. So guys, this is the difference when we are given up with the sample of hydrogen atom and just one single atom. If a sample of hydrogen atom is given to us, in that way we have plenty of atoms. They can make unique lines can be counted as N2 minus N1 into N2 minus N1 plus 1 by 2. But if you are given up with, already you are given up with the, what I must say, just one atom, then maximum it can fall 1 by 1 and the maximum of line will be N2 minus N1 only. So now I think we should start solving some question. The question says that the number of visible line when an electron returns from the 5th orbit to ground state in hydrogen spectra. Number of line visible when an electron returns from 5th orbit to ground state in hydrogen. So guys, we all know that capital N will become what? N2 minus N1 into N2 minus N1 plus 1 divided by 2. Then it will give you 10. Then another question, in an hydrogen atom, the fourth stationary state, right now we are having fourth stationary state, means N equals to 4. Fourth excited state would have become 5. This is N is equals to 4. What is the maximum number of spectral lines that it can be observed if it de-excited to ground state? Then N1 is given to you 1. So it's simple that 4 minus 1 into 4 minus 1 plus 1 by 2. So 4 into 3 is 12 by 2 is 6. It's a very easy question. A is the correct answer. This is a very important question. So guys, this question has a story. So guys, this question, what I'm telling you right now, anyways, I'll record this question for shorts purpose. Anyways, guys, this question has a story. So when at my time of coaching, when I was studying in Kota, and in my class, ongoing class, my teacher asked me that who can give me the answer of this question. Exactly the similar question was there. Please read out this question. Calculate the number of possible spectral lines which may be emitted if electron return from N equals to 5 to ground, but the condition is such that none of them will be visible region. That means none of the electron is allowed to jump to second shell, or we can say N equals to 2. So just draw 5 lines, 1, 2, 3, 4 and 5. And now make all the transitions possible. So all the transition as in 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So guys, out of these lines, we have to remove those lines which belong to visible region, because none of the electron went to the N equals to 2. That is why the visible lines are not visible. So now you need to omit out some lines. What these lines are? N equals to 2. Just remove these 3 lines. Cut them up. Now the correct answer should be what? You might be thinking 7. It is absolutely not. You must think if none of the electron is returning to N equals to 2, then how come an electron is coming from 2 to 1? You have to remove this line also. And that's what I'm saying. The correct answer should be 6. And I was the one who gave this answer. That day it made me feel proud. So guys, that is it. Next, after hydrogen emission spectra, we have dual nature of matter. Dual nature of matter. So what is dual nature of matter, everyone? So guys, matter can show 2 types of nature. One of them is called as particle nature. The particle nature of a matter can be explained by its mass, momentum, particle nature, right? Volume, interparticle attraction. So many things are there which can explain this particle nature of the matter, even thermal energy. But now coming to the wave nature of a matter. The wave nature of matter that makes it matter waves. That makes it matter waves is explained by these 2 important phenomena, or the concepts that we are right now going to study. One of them is called as de Broglie hypothesis. The another one is called as Heisenberg's uncertainty principle. We have to understand these concepts. These are very much known to all of us. We are not concerned about the particle nature. We already know a matter possesses a particle nature. It has mass, volume, interparticle force of attraction, interparticle spaces and all. We are concerned about these two important parameters. One of them is called as de Broglie hypothesis and the another one is called as let it be. So guys, de Broglie simply said that, let me derive what de Broglie said. So guys, we already know. So energy is equals to, energy of a photon is equals to hc by lambda. Who gave this equation? Planck's equation, or let's say it is the Max Planck's rule, and this represents the particle nature. Particle nature. So energy of something is equals to hc by lambda. Similarly, energy is equals to mc square. Explains the wave nature. This was given by Max Planck. This was given by one and only none other than Albert Einstein. Now if you combine these two, what you will get? That hc by lambda must be equals to mc square. This is called as dual nature of matter. So this dual nature explains us that after removing what is the speed saying, we will simply get lambda is equals to h by mc. This mc is called as linear momentum p, mass into velocity, becomes h by p. This is called as de Broglie wavelength, dBW. So de Broglie explains that every matter can have its own wavelength, and these waves are called as matter wave. And for a matter wave, the lambda de Broglie wavelength is equals to h by p. P is the linear momentum. So de Broglie hypothesis also said one more thing that will amuse you. Like if we compare the de Broglie hypothesis with Bohr's atomic model. So Bohr said that MVR is equals to NH upon 2 pi, where N is the number of shell. N is the number of shell, or we can say orbit. But according to our de Broglie, we know that M into V. Let's say we say it, just cross multiply it, guys, and just simply write 2 pi r is equals to n h upon mv, and h upon mv is what? Lambda. So 2 pi r is equals to n lambda. There n becomes what? Number of waves. Can you find the similarity between these two? One of them is saying it is shell, another one is saying it is number of waves. That means every electron in its shell makes exactly the same number of waves by what number the shell belongs to. In first shell, an electron makes one wave. Second shell, it makes two waves. In third, it makes three waves, four waves, 5, 6, like that. So that's the beauty of this concept. By relating our two concepts, de Broglie hypothesis with Bohr's, we got n is equals to number of shell as well as n equals to number of orbits. Now we have another equation for this, that guys, you might have heard of this thing, that kinetic energy is what? Linear momentum we talk about, like relation between You might have heard this thing in physics also, and I can also derive it. It is actually relation between linear momentum P versus kinetic energy. So what is the relation? Linear momentum mv 1 upon under root of 2m kinetic energy. No yaar, not like that. It's simply root of 2 times of m kinetic energy. Getting me? So that's how you do it. And now simply you will come and then find out the same formula. Since earlier it was lambda is equals to h by p, or lambda is equals to h upon mv, now it has become lambda is equals to h upon under root of 2m of kinetic energy. It's very simple. How easy is that? We can do one more thing. In terms of stopping potential, we can use E into V as kinetic energy, and then we can apply the same formula. I don't know, AC is not working, I guess. Next, we have a question here, everyone. We have a question that a 0.66 kilogram ball is moving with a speed of 100 meter per second, and it is associated with a wavelength of what? So I think this question part will be done in my practice session only, but only this question I can guide you up to. So lambda is equals to h by mv. So h is 6.6 into 10 to the power minus 34 given to us. Mass is actually given us 0.66 multiplied by, we have velocity which is 100. So I guess this is simply coming up as 10 to the power, see, 10, 1 by 10. So 1 by 35, 10 to the power minus 35 meter. This is how you do it. See. Those who haven't liked the session, do like the session, yaar. Guys, now I won't waste too much of time on that concept. I'll come back to Heisenberg uncertainty. And believe me, I'll give you the perfect explanation behind it. The perfect explanation simply says that first of all, you must know that there are two things in the life, in the world, in the existence. One of them is called as macroscopic object. Another one is called as microscopic object. Guys, macro versus micro can be defined on this basis that a macroscopic object is visible by naked eyes. Anything that comes, what you can see is the example: car, chair, table, human beings, pen, pencil, etc., ball. This is something like very small object which can't be seen by naked eyes. If something cannot be seen by naked eyes, it is called as microscopic object. And the examples are electron, proton, atom, molecule, ion, etc. So guys, our particle nature will be pretty much dominant up to microscopic. So what we can say that particle nature is dominant particle nature is dominant, but over here microscopic, for microscopic, wave nature is dominant. So that is why now we will come up with the next story, the next contribution towards the atomic theory, wave mechanical model. But how? Right after introducing the wave nature. For bit set, okay, I'll make one strategy video, no problem. So now Heisenberg's, what did Heisenberg say? Heisenberg simply say that it is impossible, read it out, it is impossible to determine simultaneously the exact position and exact velocity of an electron. Guys, if you want to follow me and if you don't want to fall in unnecessary of this explanation, I'll give you one simplest formula to all learn about. Mathematically, Heisenberg simply said that product of the uncertainty in position into uncertainty into momentum is greater than equals to h upon 4 pi, which is experimentally driven. So no need to just rote learn anything apart from this, simply just solved it and we made a formula that delta x into m into delta v. M goes there, so it becomes delta x delta v greater than h upon 4 pi m. That's it, nothing else. And everything you know already. Got it? You can also take the value of h cross, h upon 2 pi, sometimes wherever you want to use, as 1 into 10 to the power minus 34. Now I'll come and solve some questions. There is a question that the position of both of an electron and helium atom within 1 micrometer, and further the momentum, it's very simple, yaar. Then the minimum uncertainty measurement of the momentum will be what? A only. Whatever it is given over there, the same will become 5 10 to the power this d. Now we have Schrodinger's wave equation, and the final part of this chapter. Apart from that, we will be having quantum number and electronic configuration also, but we will finish that on time. Now what we have is called as Schrodinger. So what Schrodinger came up with? Schrodinger said that Schrodinger took into this account that an electron is a microscopic object and that has a dominant wave character. So we have to consider electron as a wave, and he studied all the characteristics of an electron and derived so many equations, Schrodinger wave equations on the electron of different shells and subshells, and gave an equation like H, what is this, Hamilton of psi equals to E of psi. H is called as the Hamiltonian operator, which exactly represents the sum of all energies. E is also called as the total energy. So guys, my simple way of writing this expression is that del square psi plus 8 pi square m by h square into E minus V into psi is equals to 0. That is called as this equation, Schrodinger's wave equation. This can also be written as del 2 psi by dx square, del 2 psi by dy square, del 2 psi dz square plus 8 pi square m by h square E minus V psi is equals to 0. This is the expansion of this equation, and this is exactly telling us that a similar kind of equation can be given for any of the electron present in any subshell. We are not supposed to learn this thing down. Only once a question has been asked in JEE Advanced that which of the following belongs to the Schrodinger wave equation, where whatever the equation is given, that matches every time. And in that question also it matched with all the equation. The one of the equation was this, the another equation was this, another equation is this, all of them were correct answer. So now we are not concerned about what these values are. We are concerned about the final outcome of this equation. So guys, after solving that equation, we get three outcomes. So let me write it. Okay, for any orbital on solving above equation, we get three solutions. N, principal quantum number. L, azimuthal quantum number. And M, magnetic quantum number. And this is how it is represented: psi NLM. Psi NLM. NLM are representing you the respective quantum number. So guys, just read it out ASAP. That, let me sit first. That after solving the Schrodinger's equation, we get various wave functions psi 1, psi 2, psi 3, and with the total energies of E1, E2, E3 respectively. Psi has no such physical significance because psi simply represents the wave function, and square of psi represents the probability of finding of an electron, probability density of finding of an electron. An orbital is a region where probability of finding of electron is nearly 100% or maximum, and node is somewhere which is it almost reaches to 0, and finding of electron becomes what? Psi square reaches to 0. Then a question in IIT JEE 2004 was asked that the Schrodinger wave equation for hydrogen atom is what? Where A naught is the Bohr radius. If radius is zup, 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 we'll see it. So guys, it's very simple that you need to put @ node, or what you see @ r is equals to, well, let's say we are right now at the radius, r is equals to r naught. Psi square becomes 0. There is a node. We get a radial node there along the radius. So if you put psi square as 0, this portion has no significance. Putting in 0, this has the significance. So 2 minus r naught by a naught is equals to 0. So that is why you receive, then find the r naught in terms of a naught. So r naught will be equals to 2a naught. 2a naught is the correct answer. As simple as that. This was back asked in JEE Main, IIT JEE 2004, a long time back. Now we have quantum numbers, the address of electrons, the exact address of electron. So let us say if we want to find a person, and let's say the person name is Sanjay Arya. So you need to find out its country first to find a person. To find a person, where would you go? First you go to the city, street, house, room. In the similar way, if you want to find an electron, to find an electron, then you need to go to shell, then subshell, then orbital, which contains maximum 2 electrons with opposite spin, and then to its spin. So shell is represented by principal quantum number, subshell by azimuthal quantum number, orbital by magnetic quantum number, and spin by spin quantum number. Getting me? That is the importance of quantum number. Now I'll explain every quantum number one by one and we'll get our knowledge up to there. So quantum numbers is a large number of orbitals are possible in an atom. In order to represent one specifically by its shape, size and orientation, we required NLM, that is Newton's laws of motion. No, principal quantum number, essential quantum number, magnetic quantum number. Then an orbital of small size means there is more chance of finding the electron near to the nucleus. Shape and orientation means that there is more probability of finding of electron along some particular direction. Then atomic orbitals are distinguished by the quantum number, and then like that. So I'll explain one by one. First is principal quantum number. So guys, principal quantum number gives us an idea of shells. Principal idea gives us an idea of what? What does it represent? Represents shell. Represents shell. N is equals to 1 K shell, N equals to 2 L shell, like that. See. It also gives us an idea of the size and energy. The size of the nth shell can be given by Bohr's law. Bohr's atomic model 0.529 n square by z angstrom, and energy can be given as minus 13.6 z square by n square electron volt per atom. Maximum number of shells, maximum number of electrons are in nth shell 2n square, also given by Bohr, and maximum number of orbitals allowed will be half of 2n square, that will be n square. This is given here, so read it out just. Then comes azimuthal quantum number, exactly represents the subshell. It what represents? Subshell. What is a subshell? S subshell, P subshell, D subshell, F subshell, like that. So value of L decides the value of subshell. Value of L comes from the 0, 1, 2, 0 to n minus 1, always lesser than the value of n. And the value of 0 stands for S subshell, 1 for P, 2 for D, 3 for F, 4 for G, like that. And the number of subshells in principal shell is equal to the value of n. So total values are actually n, because it is 0 to n minus 1. 0 to n minus 1, if you count it, it will come up as n only. Then we have orbital angular momentum. Orbital angular momentum is also given as L into L plus 1 h upon 2 pi, which can also be written down as root of L into, L is the value of azimuthal quantum number that you must know by knowing the subshell, L into L plus 1 h cross. And this is different from the Bohr's angular momentum we just studied. Okay, let us bring some energy back and let us know what is the magnetic quantum number. So guys, a magnetic quantum number gives us an idea of the orbitals. It gives us an idea of what? Orbitals. So orbitals actually contain two electrons, one with plus half, another in minus half spin. And for any subshell, if L is defined, there will be like 2L plus 1 total values of M minus L2 plus L. So I will bring you to one example and then you will absolutely able to relate them. So let us suppose we have L over here, azimuthal quantum number, and the value should be L. So for L, total values of M will be what? Total values of M, magnetic quantum number, will be equals to 2 times of L plus 1. Then there comes the values of M, and that also minus L2 plus L including 0. Right, let me just start. The first one value could be 0. 0 means we are talking about the S subshell. For S subshell, total values of 2L plus 1 will be 1. The 1 value will be 0, and there we can represent it like this, and it is none other than S subshell or S orbital. The number of subshell and orbital are the same. There is like S subshell has only one orbital. Let's say the value is 1, we call it P orbital. P subshell, yeah, sorry, because L represents the subshells only. Value of M will become what? 2 times of 1 plus 1 is equals to 3. Values individually are minus 1, 0, plus 1. It will be represented like 3 boxes. One of them is called as Px, Py, Pz. Getting me? This is your P orbitals. These are 3 P orbitals. Then comes 2. 2 stands for D subshell. D subshell can have total of 2 into 2 plus 1, 5 orbitals. What are these 5 orbitals? 1, 2, 1, 2, 3, 4, 5. Names respectively. So this could be your minus 2, minus 1, 0, 1, 2. This is your dxy, dyz, but believe me, this is something different. This is dz square. Matlab IUPAC has accepted its value of magnetic quantum number as 0 for dz square orbital. Then this is your d, the left one xz, and dx square minus y square. So guys, this is how you can assign the values of magnetic quantum number if you are as of now given up with the L, azimuthal quantum number, and you can find out the magnetic quantum number. So anyways, we will reach out to the last. We have spin quantum number, everybody. Spin quantum number is saying that although shell can be same, subshell can be same, even you can have the same orbital, but the number of electron present in orbital, 2 electron, must have different spins, and that spin is arbitrarily decided by the spin quantum number. So this is not derived from the Heisenberg's uncertainty. Heisenberg's nahi yaar. This is something that we have not derived from the Schrodinger wave equation. We have directly taken it. We have arbitrarily assigned this value. So that is why this can have two values of positive half or minus half, representing clock versus anti-clock spin, and either way can be of either way. Either way can have the either value, like anti-clock can have plus half, clockwise can have minus half, or this arrow, down arrow, up arrow, anything can be represented anywhere. This is represented like this. This could be represented like this. Anyway is fine. Now there are only two values of spin quantum number, plus half and minus half. Then these are called as two spin states of the electron and are normally represented by arrows, and they have no significance of their values of plus half and minus half. They are just arbitrarily assigned number. Next question is the orbital angular momentum of electron in 2s orbital. Orbital angular momentum is what? L for 2s will become what? 0 for any s subshell. If s subshell is given to you, L is equals to 0. So you can find out the angular momentum, capital M, is equals to root of L into L plus 1, H cross, it will become what? H cross only. H upon 2 pi, C. Which of the following pair of d orbitals will have electron density along the axis? That is good question. Number of spectral line पढ़ लो बेटा एक बार. I have covered this part previously. Just go visit it. Exactly some half an hour, 1 hour back. You will come to know of it. So guys, for this at least I must give you the structures and the shapes of all the orbitals. I'll explain you now. Shapes of orbitals. Because right after knowing the shapes of orbital, you can only go for knowing the nodes and everything. Number 1 is S subshell. So basically S subshell is S subshell nahi hai, S orbital. So guys, S orbital is spherical in shape. This is spherical in shape. And the structure looks like this. There is a positive charge nucleus, and around the nucleus there is electron density like this. So let's say this is 1s. So now 1s to 2s, if you come, no doubt will be a bit bigger. So this is how it look like. This is your 1s. Then 1 and 2 will have gap because this is quantized model. You cannot have electrons everywhere. So then comes your 2s. So this is the structure of, this is how 2s look like. Then comes to 3s. So this is how it look like. So guys, this is your 3s and so on. So can you see, like, there are like radial nodes you can find. So along the radius, if you go, this is like one radial node. Okay, along the radius, if we go, there is like one spherical or radial node. And here we can find 1 and plus 1. We have 2 radial nodes. This is what about we have 1s, 2s and 3s. And that was one orbital, s orbital. The next is p orbital. P orbitals are dumbbell in shape. P orbitals are what? Dumbbell in shape. And this is how it look like. This is your 2p because start from second only. Second only, why? Because it has L is equals to 1. If it has L equals to 1, the minimum number of n should be 2. Remember, this is 2p. So let's say if I have to draw 3p, this is how 2p look like? This is how it look like. This is your 2p, this is your 3p. So how many radial node can you find? See, one radial node along the radius. Anyways, you can also give us we can also find angular node also. Angular node is something that and we also have no angular node or nodal plane. So you cannot find, guys, any angular node or nodal plane in s orbital, whereas in p you can find it. So angular node is what? So let's say this is your x-axis. Let us say this is the x-axis. So a plane which is perpendicular to x-axis, plane perpendicular to x-axis will be yz plane is equals to the nodal plane. Nodal plane. So you can say that angular node will be equals to 1, and that is yz plane here. So that's how you can find out the values of angular node also in. Sir, C2 molecule के बारे में बताओ कुछ. क्यों बताओ भाई? Like, why are we welcoming these suggestions? We are not having any ask me anything session, guys. Let me finish the atomic structure first, yeah. And then we have, everybody, d orbitals. D orbitals are usually under two categories. One of them is called as planar or non-axial. So non-axial orbitals are made like this, which do not lie on the axis. This is x, this is y. This is dxy. This is yz. And then comes this is xz. But all of them are non-axial. They do not lie on the axis. The another category is called as axial. Axial orbitals. So what are axial orbitals? Along the axis. So this is, let's say, x, this is y. So lobes will come, the electron density will come along the axis. These this chicken leg piece looking like species is called as a lobe, which is representing the electron density somewhere. And the another, this is called as dx square y square. Then we have dz square, just along the z axis. Let's say this is z axis, so along to this only we have. And there is also one ring. This is called as dz square, baby soother orbital. Its shape is look like that only. It's also called as baby soother orbital. So this is something about the orbitals, and that will give you an idea about the node somewhere. So first of all, let us know what quantum numbers are. So let us solve some question of quantum number. Quantum number is already completed. Quantum numbers application we have to know. So let us suppose that quantum number is asked that which of the following set of quantum number is not possible. So you do one thing, that just identify, pick everything one by one, and then you need to give the correct answer. So this is like n is 3, L could be 0, M is 0, this is correct, this is also correct, this is also correct, can be correct. This is not the correct answer. N is 0, N is 2, correct. L cannot be 2, as you all know that value of L is 0 to n minus 1. It cannot be, n cannot be equals to L. So that is why this is incorrect. Then this is 4, 3 minus 2 minus half. This is also correct. This is correct, 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 correct. Then fourth one, 1, 0 is fine. This cannot be minus 1 because this values comes from what? Minus 0 to plus 0. Minus L to plus only this can have the value. So this is incorrect actually. Given this value is incorrect. Since it is incorrect, it will be incorrect. Then for number of n, 3, shell is third, subshell 0 to L minus 1, that is 0 to 2. This is good, this is good. But value of 3 is not possible, minus L to plus L. M has a value of minus L to plus L. Then how come 3 is possible? 3 is incorrect, it is incorrect, it is also incorrect. So first, no, second, fourth, fifth. Second, fourth, fifth are incorrect. Second, fourth, fifth, C option. Then guys, nodes we had. So radial nodes along the radius, we also call them spherical node. There's a very simple formula to find them, Rn. N minus L minus 1. Just simply, if you know the azimuthal quantum number, principal quantum number, you can easily find out. An azimuthal quantum number, sorry, angular node, or let us call it a nodal plane. These are the same only. Nodal plane or angular node will be equals to just the value of L. And if you find out the total nodes, radial node plus angular node, sum them, it will become n minus 1. That is how you find the number of total nodes. Now orbitals having 3 angular nodes and 3 total node will be what? So radial angular node is 3. That means L is equals to 3 and L is 3 for S subshell. And it has how many? 0, radial node is 0. So from where it starts, S starts for 1, P starts for 2, 3 starts D, and then it 4. This is like 4F subshell, 4F orbital. Guys, we have an important graphs over here. So I'll give you an idea how do you draw the graph, and let's see. So number one is wave function. You know wave function, psi versus radial distance r. This graph, how does it look like? See, number one, for 1s, 2s, 3s orbitals. So let us say if we are going for 1s first, the graph starts from infinity because its nucleus itself is like infinite. We had psi, this is r, there is a positive sign here. Similarly, if we are going for 2s, there will be one radial node along the radius. So you have to cut this line once. Graph comes like this. This is plus, this is minus, this is radial distance r, this is psi, 2s. And then for 3s, same graph but with 2 times cutting the graph like this. This is plus, this is minus, this is plus. This is psi, this is r. I don't think any doubt is there. This is for s orbitals. These are wave function versus r for s orbital. Now what if I take the same example for second case I'm taking for 2s. So for other orbitals, for other than s orbital. So guys, this could be, now this will start from the 0, rest all of them have 0. This is for, this is r, this is psi, this is for 2s, not 2s, this is not for s, this is not for s, this is for 2p, 3d, 4f, etc. These orbitals will have the same diagram. Then if I make it cut from one end and then leave it like this, plus and minus, this is psi, this is r. Why am I decreasing it? Because the probability as well as the function value will keep on decreasing with going away from the nucleus. It is maximum nearby to the nucleus, and then it is 0 also at the nucleus for other orbitals. For s orbital it is maximum. This is for 3p, because why am I saying it for 3p? This is 3p, 4d, 5f, etc. because there is a, we see one radial node. Similarly, third one could be like that. Psi versus r. Radial distance, this is psi. So how many nodes can you see? 1 and 2. These two are the radial nodes. So what this can be? The orbitals which can be 4p, 5d, 6f, on etc. 2 radial nodes are there. Number 2 is the graph. Second graph are for electron probability density versus r. What you need to do, whatever you made it for psi versus r, just make it positive. Just simply do it the positive. How? Let us say for 1s, what did we make till now? Psi square, this is r, same only. For 2s, you remember for 2s we were going below x-axis, like below the axis in negative words, but here it will come here like this is how it will go. Psi square versus r. This is called as radial node. Then comes 3s. Then the graph comes psi square versus r. How many radial nodes are there? Radial nodes are 2. 2 radial nodes are there. This is how we make 1s, 2s, 3s. And the same we can make it for, let's say 2p, 3d, 4f, etc. Then the graph comes up like this. No doubt it will start from 0 and then go like this. Psi square versus r. Let's say this is for 3d, not 3d, 3p, 4d, 5f, etc. Then the graph comes like this. Starting from 0, cutting at one position, declination, and then go down. This is psi square versus r. How many radial node? 1. Let's say this itself has for 4p, 5d, etc. So then it will become like that, psi square versus r. But declination should be there. 2 radial nodes you can find. Wherever it is touching, 2 radial nodes are there. But always make sure that this height should be declination. Third type of graph. Third type of graph is radial probability versus radius or the distance radial. This is radial probability, everyone. So let us say this is something. This length is, let's say, dr, and this is r. So the volume will become 4 pi r square dr, and the density, probability density, psi square. So if you multiply them, you will get probability of finding of electron. Electron probability will be volume into density. So volume is 4 pi r square psi square into dr. This is your. So now I'll make this graph for, this is same for 1s, 2p, 3d, because this is starting from origin and it has r terms in it, because r can become 0 at nucleus. So 3d, 4f, for all of these the graph looks like this, very simply 0 at shuru and then it goes into infinity. This is your 4 pi r square psi square dr versus r. Then similarly, if I make it for 2s, 3p, 4d, 5f like that, then the graph will have this way, 1, and then increase it because radius is increasing like that. So this will go for increasing, and this 1 is actually radial node like that. Clear? Oh, I'm feeling tired now. Now try this question, guys. On the basis of a given diagram, which of the following statement is incorrect? 1s and 2s orbitals are spherical in shape, सही है. Probability of finding of electron is maximum in nucleus, सही है. The probability of finding of electron and give it equal है, सही है. The probability density of 2s decreases. No, it doesn't decrease uniformly. It varies like this. I told you this, like this for 2s orbital. This graph is between psi square and r. There is one radial node also. This graph is for C. This is the radial node, and this is coming from infinity. This is absolutely for 2s. Fine. Guys, last topic of the day, which is filling rules of filling electrons, and I'm a bit tired. I'll give you this idea. There's one more video like atomic structure part 2 previously I made, where I explained this whole part of Schrodinger wave equation, writing electronic configuration all. You can also copy and tally from there, and if not, then we will take an idea and we'll go a bit fast and we'll try to wind up the session from here. Actually, AC is not working. It's being very exhaustive here. Rules for finding electron, filling electron. So there are three major rules. Off-bow, n plus L comes under off-bow, Hund's rule or Pauli exclusion. Off-bow says that you have to fill the electron in increasing order of electron, and increasing order decided by n plus L rule. So what is n plus L rule? N plus L will simply says that, let's say we have 3D and 4s. So you need to first check out the value of n plus L. L value of D is 2. This is coming 5. This is 4 plus 0 coming 4. Which one is greater than this one? This one has higher energy. This is the order of energy. If this is the order of energy, which should fill first? 3D or 4s? 4s will be filled first. Like that. If two orbitals are the same value, let us suppose 3p versus 4s. This is also having 3 plus 1 is equals to 4. This is only 4 plus 0 is equals to 4. If this is same, then you need to check out the n value, this 3 value, and this 3 value is coming lesser for this. This will be having the order of energy. 3p is first before 4s, and 3p is filled first. See? Then we have Hund's rule of maximum multiplicity, that pairing of electron will not occur until unless all the degenerate orbitals are singly filled in the same direction. It means that, let us suppose if I have to fill the electronic configuration of oxygen. So oxygen has a configuration of 2p4. So how are you going to fill 2p4? This is correct, but you cannot fill singly like this. You cannot fill like this. You can also fill it like this. Down arrow, up and down arrow. This is also good. We could fill either of the way. But they should all be in single side while you're filling it, and then the next electron will come after pairing. And Pauli's exclusion rule says that no two electron can have all four same set of quantum number. That's why if shell is same, subshell is same, everything is same, then at least they must have different spins. So guys, I will have to quit the class from here. You better try these questions. I'll insert these questions also in my upcoming class. Or the one when we'll be solving the problems, practice problem. There I will explain some of the electronic configuration related part. Quantum number and everything is already sorted to us. I'll make a video, and video will be how to write the electronic configuration. So that we'll do in our next class. As I feel so tired, I have to depart now. Thank you so much for your patience. So you can join our All India mock test series. Join it now only.